Imagine a civilization so advanced it seems to whisper secrets across thousands of years. The Sumerians, who lived over 5,000 years ago in the cradle of civilization, left behind artifacts, texts, and monuments that defy easy explanation. From impossible engineering feats to knowledge of the stars, medicine, and mathematics that rivals later discoveries, they hint at understanding far beyond their time. Get ready to explore astonishing Sumerian mysteries that continue to baffle scientists and historians alike. Each discovery challenges what we think we know about human history, urging us to ask, did the Sumerians glimpse truths that remain hidden to us today? The enigmatic origins of the Sumerians. The land between the Tigris and Euphrates holds the ruins of the world's first cities. Long before Rome, before Greece, and even before Egypt's Great Pyramids, the Sumerians shaped a civilization that appeared almost suddenly around 4000 BCE. Yet the question of where these people came from and how they carried such advanced knowledge into the fertile plains of Mesopotamia remains one of the deepest mysteries in archaeology. The clay tablets they left behind give us voices from 5,000 years ago. Those texts tell stories of gods, kings, and the ordering of the heavens, but they do not tell us who the Sumerians themselves were. Their own myths describe gifts of knowledge arriving fully formed from divine beings, as if writing, agriculture, and law were not discovered but handed down. Historians searching for a cultural prelude, a stage before Sumer, have found no clear origin that explains the sudden flowering of their society. That language provides one of the sharpest clues, yet it deepens the puzzle. Sumerian is what linguists call a language isolate, meaning it has no known relatives. Akkadian, which later grew alongside it, belongs to the Semitic family, linking it to Hebrew and Arabic. But Sumerian stands apart, unrelated to any living or dead tongue we can trace. Attempts to connect it to languages in the Caucasus, the Indus Valley, or even distant Asia have never reached agreement. It is as though this language, the first ever written down, has no ancestors at all. Archaeological records show people living in Mesopotamia long before the rise of Sumer. Small villages existed during the Ubidae period, dating back to at least 6500 BCE. Yet these settlements were simple and largely uniform, with no signs of the grand temples, libraries, or bureaucracy that would later dominate Sumerian life. Then within a few centuries, cities such as Uruk, Urdu and Lagash emerged with monumental architecture and organised government. The leap from scattered villages to sprawling city-states appears far too steep to explain with gradual progress alone. Uruk, often called the world's first true city, rose around 3500 BCE. With a population that may have reached tens of thousands, its ziggurats towered over the plain, and its streets teemed with markets, scribes and priests. The question is not only how such a city came to exist so early, but who carried the skills needed to build it. No nearby culture provides evidence of influencing them on this scale. The invention of ununiform writing in Uruk further complicates the story, since it appears fully developed rather than in tentative stages. The Sumerians themselves preserved lists of their earliest rulers, known today as the Sumerian king list. It speaks of dynasties stretching back before the flood, with reigns lasting thousands of years. Scholars do not take those lengths literally, yet the record reflects a deep memory of a past long before archaeology can verify. These stories hint at a heritage that the Sumerians believed did not begin in Mesopotamia, but was rooted in something even older, something they themselves looked back upon with awe. Clues in material culture add to the enigma. Certain motifs in pottery and seal designs show sudden sophistication, as if artistic traditions matured in an instant. The stone tools gave way to metalwork earlier than expected, and complex religious systems appeared without known precedent. If gradual development had taken place elsewhere, it would have left little trace for modern researchers to uncover. The suddenness of these advances continues to spark debate among archaeologists. One possibility considered is migration. Could a group from another region have entered Mesopotamia and established what we now call Sumer? Yet, when scholars search surrounding lands for a culture advanced enough to be the parent of Sumer, the trail goes cold. The Indus Valley to the east did not reach its height until much later. Egypt developed around the same time, not before. Anatolia, the Levant and Iran held early settlements, but none display the clear signs of being the missing source. And even the genetic evidence leaves questions open. Ancient DNA studies suggest connections between Sumerians and earlier local populations of Mesopotamia, but the data are limited and fragmentary. It indicates continuity in the region but does not explain the sudden leap in cultural achievement. If they were simply descendants of the obeyed villages, why did civilization ignite so abruptly in their hands? Science has not yet given a decisive answer. Historians continue to examine how the environment might have played a role. The flooding of the rivers deposited fertile soil which could have supported larger populations. Yet fertile land alone cannot explain the invention of writing, mathematics, and organized religion. Many fertile regions in the ancient world did not produce the same leap. That something about the Sumerians' knowledge or perhaps their inherited traditions pushed them far beyond what the landscape alone should have allowed. Ancient texts sometimes describe the Sumerians as receivers of knowledge from their gods, the Anunnaki. To the people themselves, their sudden rise was not a mystery but a gift. While scholars view these as myths, the detail with which Sumerians credited the gods for agriculture, astronomy, and architecture suggests they themselves struggled to explain how such knowledge first appeared. Their myths may be echoes of a lost history we can no longer reconstruct. The enigma only grows when we consider how quickly later cultures adopted Sumerian ideas. The Akkadians borrowed heavily from Sumerian writing and myth. Babylonian astronomy and law traced their roots to Sumer. Even far later, the Greek and Hebrew traditions echoed themes first recorded on clay tablets in Uruk, how the very first civilization managed to shape those that followed. When its own beginnings remain hidden, is one of history's greatest riddles. The cradle of civilization remains a cradle of unanswered questions, and the Sumerians still stand at the threshold of human history with origins cloaked in silence. The sudden rise of civilization. Travelers standing on the edge of the ruins of Uruk are often struck by their scale. Even in decay, the outlines of vast temples and long-buried streets suggest a city that once throbbed with life. To imagine it thriving more than 5,000 years ago is to confront a mystery that continues to puzzle historians. How did a society so advanced appear in Mesopotamia with such speed? The first clear signs of urban life in southern Mesopotamia appear around 4000 BCE. Before that, small farming villages dotted the region, living off irrigation and simple agriculture. Within only a few centuries, those modest settlements gave way to sprawling city-states. Uruk, Eridu, and Lagash rose with monumental temples, central authorities, and complex systems of writing and trade. The jump from scattered hamlets to sophisticated urban centres seems far too sudden for gradual change alone. Archaeological layers at sites like Uruk show this transition in striking detail. Beneath later city walls lie traces of humble mud brick houses, simple tools, and small communal shrines. Above them appear massive platforms, monumental ziggurats, and organised neighbourhoods. Though the speed at which these developments occurred has led researchers to ask whether cultural knowledge was introduced from outside or whether an internal force propelled the change. Clay tablets revealed part of the story. In the late 4th millennium BCE, writing emerged not as a primitive system of scratches, but as fully formed cuneiform. The earliest tablets already record transactions, lists, and even myths suggesting a mature system at its birth. If writing was invented gradually, the earlier stages are missing. It is as if the Sumerians moved from silence to script almost overnight. The rise of administration matched the rise of writing. Temples became not just places of worship, but economic engines, directing labour, land, and trade. Priests recorded offerings, organised workers, and managed the distribution of food. And this level of control and record-keeping points to a sudden centralisation of power. Small villages rarely show such organisation, yet in Mesopotamia it appeared fully developed in the earliest known cities. Trade provides another clue. Artefacts from Uruk include materials not native to southern Mesopotamia. Lapis lazuli came from Afghanistan, cedar from Lebanon, and copper from Oman. Long-distance dance trade networks were already in place when these cities flourished. How such far-reaching connections appeared so early remains a mystery, since there is little evidence of a slow build-up of commerce leading to it. The population boom is equally striking. Estimates suggest Uruk may have held more than 40,000 people at its height in the 4th millennium BCE, making it the largest city in the world at the time. For comparison, most human communities before this period consisted of only a few hundred individuals. The shift from small kin-based groups to large urban centres required new social structures that seem to have appeared almost all at once. Art and symbolism also reveal the transformation. Cylinder seals depict complex religious scenes and intricate patterns, demonstrating not only advanced craftsmanship but also an established worldview. These artifacts show a culture already confident in its visual language. Unlike in other regions where artistic traditions often grow slowly over centuries, Sumerian art enters the record in a state of maturity. Scholars have debated whether the sudden rise was the product of internal invention or outside influence. Some argue that earlier cultures such as the Ube laid the groundwork and providing irrigation and simple forms of social hierarchy. Others suggest that migrants brought advanced traditions into Mesopotamia, though no source culture has been definitively identified. Both theorists struggle to explain the rapid pace and scale of the change. Environmental factors may have played a role. The fertile floodplains of the Tigris and Euphrates provided abundant harvests supporting larger populations. The rivers also created natural trade routes connecting settlements across wide distances. Yet many fertile regions in the ancient world never produced such swift leaps in culture. The landscape offered opportunity, but it does not fully explain the sudden appearance of monumental cities and written language. Religious tradition provides another perspective. In Sumerian myths, civilization itself was a gift from the gods. Writing, agriculture, and kingship were said to have been handed down, not discovered. While these are myths, they reveal how the Sumerians themselves viewed their sudden rise. They did not see their achievements as gradual progress, but as a legacy of knowledge delivered to them from beyond. One of the most striking signs of this leap is mathematics. The Sumerians used a base 60 system allowing for complex calculations in trade, astronomy, and administration. This system, still preserved in the way we measure time, was already in place by the time records began. Simple counting systems are known to have preceded it, leaving unanswered questions about how such an advanced method appeared at the very dawn of civilization. The question of leadership adds to the puzzle. The earliest kings of Sumer appear not as local chiefs but as rulers commanding armies, organizing irrigation, and directing monumental construction. The scale of their authority suggests the existence of political systems far more advanced than those expected in early societies. Yet the origins of this authority remain as unclear as the origins of the people themselves. Later civilizations inherited much from the Sumerians. Babylonian law, Assyrian architecture, and even aspects of Greek philosophy trace their lineage back to ideas first recorded in Sumer. The fact that so many later cultures built upon this foundation underscores how advanced it was. Still, the question of how it appeared so quickly has not been answered. Something still unseen lies between the quiet villages of Mesopotamia and the towering cities that followed, and it is in that hidden space that the mystery of civilization's sudden birth continues to wait. Cuneiform, the script without a predecessor. In the British Museum, shelves hold rows of clay tablets no bigger than a human hand. Their surfaces are covered in small wedge-shaped marks pressed long ago by reeds into wet clay. These are pieces of the first writing system known to history, cuneiform. What unsettles scholars is not only its age, but the fact that it seems to have appeared in full form, with no surviving evidence of simpler beginnings. When 19th century archaeologists first uncovered tablets in Mesopotamia, they could not read them. The strange signs bore no resemblance to Greek, Latin, or Hebrew. Over time, experts managed to decipher the patterns, revealing that these marks recorded everything from business contracts to myths. The discovery shocked the academic world because the tablets dated back to around 3100 BCE, centuries before Egyptian hieroglyphs or Chinese characters became widespread. The earliest tablets do not look like tentative experiments. Instead of a few crude symbols, they contain dozens of signs arranged in ways that show an established system. Many of the first examples are administrative records that list grain, cattle, or labourers. To keep track of these details, the scribes needed a consistent script, which means the invention must have taken place earlier, in a stage for which no evidence has yet been found. Some scholars suggest that clay tokens were used in Mesopotamia before 3300 BCE may have been a precursor. Farmers used small shapes to represent goods such as cones for grain or spheres for livestock. Eventually, the people began depressing these shapes into bronze clay tablets, rather than storing them as separate objects. This could have been the first step toward ununiform, but the leap from simple impressions to complex writing remains unexplained. Unlike alphabets, which use letters to represent sounds, early ununiform used logs, each sign standing for a word or idea. Over time, scribes adapted the system to include phonetic values, allowing it to represent spoken language more fully. Even at its earliest stage, however, the script shows a level of sophistication that does not fit neatly into a slow experimental process. The technique itself also raises questions. Cuneiform signs were created with a stylus cut from a reed pressed into soft clay. This method produced sharp wedges and lines, but it required training to master. So the uniformity of this earliest tablet suggests that scribes already had schooling. There must have been institutions to teach writing. Yet the origins of those schools remain invisible in the archaeological record. One striking feature of the earliest texts is their breadth. Within a few centuries, cuneiform recorded not only inventories, but also hymns, epics, and legal codes. The Epic of Gilgamesh, written centuries later in Akkadian, but based on earlier Sumerian stories, was preserved on clay tablets in the same script. That a writing system could carry both daily transactions and deep reflections on life and death suggests it reached maturity far faster than expected. The geographic spread of ununiform adds to the mystery. It was adopted by Akkadians, Babylonians, Assyrians, and Hittites, all of whom adapted it to their own languages. That the script lasted for more than 3,000 years, making it the longest used writing system in human history. Its persistence indicates that it was robust from the beginning, another sign that it entered the world fully developed. The appearance of ununiform also transformed human society. With writing, rulers could impose laws, merchants could formalize contracts, and priests could preserve myths. Entire administrations depended on scribes, and literacy became a powerful tool. Such a sweeping change in how people lived and governed should have left clearer traces of its invention. Yet, the decisive moment remains hidden. Excavations at Uruk have revealed tablets that belong to the earliest stages of the script. These texts, often called proto-uniform, date to the late 4th millennium BCE. They include numerical notations and pictographs, and many of which later evolved into wedge-shaped signs. Yet even here, the system is already complex. Scholars note that proto-uniform uses multiple numerical systems simultaneously, a feature that would require advanced conceptual thinking. The puzzle becomes sharper when compared to other writing systems. Egyptian hieroglyphs appear slightly later, and Chinese script emerges centuries afterward, both showing signs of gradual development. Cuneiform, by contrast, seems to leap into existence. It is the lack of a visible learning curve that makes it unique. This absence leaves open the question of whether earlier stages were lost, or whether the invention was truly abrupt. The demands of Mesopotamian society may have pushed the invention. As populations grew, managing trade, taxation, and labour required more than memory or oral record. That the pressure to control these resources could have spurred innovation. Yet this explanation does not account for why the script appears so advanced from the start. Rather than beginning as simple symbols that slowly became more complex, the role of the temple economy adds another layer. Temples managed large estates, controlled surplus grain, and directed workers. For this, they needed precise records. Some scholars believe the first scribes worked within temple walls, creating the earliest tablets as tools of accounting. If so, the invention of writing may have been tied to religious authority. But again, the missing early stages prevent a clear answer. Modern researchers continue to piece together the evolution of signs by comparing thousands of tablets. Each mark offers clues about how the system changed. Yet, the first step remains elusive. Without clear evidence of a transition from tokens to true writing, the question of how cuneiform was born remains one of the most enduring mysteries of the ancient world. What we see today in museums is the product of a system that seems to have sprung into being with little warning, leaving us to wonder what moment of brilliance or necessity sparked the first wedge pressed into clay. Advanced knowledge of astronomy. On clear nights above the Mesopotamian plains, the stars appeared brighter than anywhere crowded by modern light. The desert sky stretched wide and open, offering a perfect stage for observation. It was here that ancient people began charting the heavens with a precision that still puzzles researchers today. Clay tablets uncovered in Babylon reveal the extent of this knowledge. Some texts describe the movement of planets with methods that resemble later Greek mathematics. Others contain lists of eclipses and predictions of celestial events centuries into the future. Such detailed records raise questions about how this understanding emerged so early. The earliest astronomical tablets date to around the 2nd millennium BCE. Though fragments of older records suggest the tradition began long before, these texts often combined astronomy with astrology, linking the movement of heavenly bodies to the fate of kings and empires. What is striking, however, is the technical accuracy hidden inside what might appear at first to be mystical writings. Among the most remarkable finds are the so-called Mulapan tablets copied around 700 BCE, but preserving knowledge from earlier centuries. These documents catalogue constellations, rising and setting times, and the division of the year into seasons. They reflect a systematic effort not just to watch the sky, but to organise it, turning the stars into a structured calendar. The Babylonians were especially skilled at tracking the planet Venus. The Venus tablet of a Macetica, thought to date to the mid-2nd millennium BCE, contains a long sequence of observations of the planet's appearances and disappearances. Such careful records required not days or months, but generations of watching and writing passed down in scribal schools that must have valued patience and consistency above all. These records show more than curiosity. They reveal predictions by recognizing cycles. The Mesopotamian astronomers could forecast when Venus would next rise, or when an eclipse might darken the sun. In a world without modern instruments, this ability gave rulers power, allowing them to claim the favor of the gods or to prepare armies and harvests in an alignment with the heavens. The methods themselves were surprisingly advanced. Some Babylonian tablets from the 1st millennium BC reveal the use of mathematical techniques that parallel later Greek geometry. For example, astronomers calculated the area under curves to predict planetary motion, a concept that modern historians describe as an early form of integral thinking. How such methods arose in Mesopotamia centuries before similar ideas appeared in Greek texts remains a subject of debate. Astronomy was not limited to abstract records. The ziggurats that rose above Mesopotamian cities may have served as observation towers. Their high platforms provided clear views of the horizon, where the first or last star of a constellation could be tracked. Alignments within some temple structures also suggest that architecture was guided at least in part by astronomical considerations. The influence of this knowledge spread far beyond the region. Greek scholars such as Hipparchus and later Ptolemy built upon Babylonian records, adapting them into their own systems. Without the careful notations of Mesopotamian scribes, the development of classical astronomy might have been delayed by centuries. Yet the origins of that knowledge, the point where simple sky watching became precise science, remain hidden. Eclipses, in particular, fascinated and frightened ancient observers. The Babylonian tablets contain long lists of lunar eclipses, some stretching back hundreds of years. The ability to foresee such an event gave priests enormous authority. For kings, a correctly predicted eclipse could be used to confirm divine legitimacy, while an unexpected one could be seen as a dangerous omen. Even the division of time owes much to these observations. The Babylonian system of counting by the 60s gave us the 60-minute hour and the 360-degree circle. Both concepts stem from attempts to map the sky and measure movement with consistency. What began as an astronomical necessity has shaped how we measure time and space to this day. Yet despite this sophistication, we still lack clear evidence of how the first Mesopotamian astronomers developed their skills. The step between simple stargazing and the production of predictive tables is missing. Archaeologists uncover tablets filled with advanced calculations, but the early tentative notes that would show the path of discovery have not been found. The combination of science and divination complicates the picture further. Many tablets blend astronomical data with omens, treating the stars as messages from the gods. Some scholars argue that the practical accuracy of Babylonian astronomy stemmed from religious duty, as priests needed reliable predictions to interpret divine will. If so, the roots of science and faith in Mesopotamia were more closely entwined than we might expect. Each discovery of a tablet sharpens the mystery. Lines of numbers, symbols, and constellations reveal minds carefully at work, but they do not explain the leap that made such work possible. Somewhere in the centuries before written records, knowledge accumulated in cents until it appeared on clay with astonishing clarity. The night sky over Mesopotamia is no longer as dark as it once was, but the tablets endure, carrying with them a reminder that humanity's dialogue with the stars began earlier and with greater skill than we can easily explain. The 12-planet mystery. Among the thousands of tablets recovered from Mesopotamia, one cylinder seal has drawn unusual attention. Known as VA243, it shows a central figure surrounded by smaller orbs arranged in a pattern that some researchers argue resembles the solar system. Unlike other seals that depict gods or rituals, this one seems to hint at celestial order. With many bodies greater than the planets known to the ancients, the seal was found in the collection of the Vorderistik Museum in Berlin and has been studied for decades. Its imagery is not easily explained. At the centre is a large circle with rays often interpreted as the sun. Around it are 11 smaller shapes. If these truly represent planets, the total count would rise to 12, including Earth, which challenges the belief that ancient people recognised only 5 visible planets beyond the sun and moon. Most scholars caution against a literal reading. The shapes may not be planets, but symbols for stars or divine realms, yet the precision of the arrangement continues to provoke speculation. Why would a society from the 3rd millennium BCE carve such a pattern if it did not reflect some kind of cosmic order? The question lingers, especially because so many Sumerian texts describe the heavens in ways that feel far ahead of their time. Some researchers connect this seal to the broader Sumerian fascination with the number 12. Their calendar was divided into 12 months, and their system of counting revolved around base 60, which divides neatly into 12. The zodiac, later refined by Babylonian astronomers, was set into 12 sections. To them, the number held symbolic weight, and it may be no accident that the seal depicts 12 figures around the central star. What unsettles the mystery is that certain Sumerian myths describe the heavens with references that do not align neatly with known astronomy. In the Enuma Elish, a Babylonian creation epic rooted in older Sumerian stories, celestial battles and wandering bodies are described in detail. While clearly mythological, the narrative of additional heavenly spheres has been tied by some modern interpreters to the idea of an unseen 12th planet. The hypothesis of a hidden world gained popular attention in the 20th century through the writings of authors like Zachariah Sitchin, who argued that the seal VA243 represented the solar system, including an extra planet beyond Neptune. According to this interpretation, the Sumerians possessed knowledge they should not have had without advanced tools. Mainstream scholars, however, reject this claim, pointing out that the seal's imagery can be explained as symbolic rather than scientific. Despite academic rejection, the debate persists because of gaps in the record. The Sumerians left no surviving text that clearly explained the VA243 seal. Without a written key, interpretation is left to the viewer, and in that ambiguity lies the power of the mystery. Archaeologists prefer caution, while others see the absence of clarity as evidence that something extraordinary has been lost to time. Other artifacts add fuel to the discussion. Certain astronomical tablets list constellations in patterns that do not always match later Greek records. Some constellations appear grouped in ways that suggest a broader sky map. Whether these points refer to misunderstood knowledge of additional planets or simply different cultural frameworks for the heavens is still debated. The idea of a 12th planet also carries implications for ancient cosmology. If the Sumerians believed in more worlds than were visible, what inspired that belief? Was it purely myth shaped by their gods and creation stories? Or was it drawn from observation and oral tradition? The fact that the seal places all bodies around a central sun hints at a heliocentric concept, something that did not reappear in human thought until much later in Greece and then in the Renaissance. Critics argue that the seal may not depict the sun at all, but a star or divine emblem, which shifts the entire interpretation. If true, the surrounding figures could be deities, not planets, yet the circular forms and their ordered arrangement refuse to dismiss themselves so easily. Each explanation opens as many questions as it answers. Even the broader archaeological context offers little help. VA243 is not an isolated object, but one of many seals used for administrative or ceremonial purposes. Most show scenes of worship or mythology, yet this one introduces shapes that resist easy categorization. Why would an ordinary seal contain what looks like a map of the sky, unless it held some deeper symbolic or astronomical significance? The number 12 itself continues to echo across cultures, from 12 Olympian gods in Greece to 12 tribes of Israel until 12 signs of the zodiac. The repetition is striking. While it may stem from practical divisions of time and space, its recurrence strengthens the sense that ancient people attach profound meaning to the number, possibly tied to their understanding of the cosmos. Attempts to test the 12th planet theory in modern astronomy have not yielded evidence of such a body. While astronomers search for a possible planet 9 far beyond Neptune, it is framed as a scientific pursuit unrelated to ancient claims. Yet the coincidence of both modern science and ancient myth pointing to hidden worlds has kept the Sumerian mystery alive. The seal remains housed in Berlin, quietly displayed among countless other artifacts. visitors pass by without knowing the debates it inspires, while scholars continue to wrestle with its meaning. The small carving on Chuaguan clay has opened a question that extends far beyond its size, connecting the ancient world to modern speculation about the true shape of our solar system. No matter how carefully the seal is studied, the image seems to resist closure, as though it were designed to leave us staring not only at clay, but at the vast unanswered silence of the cosmos. The detailed lunar calendar. The moon hung above Mesopotamia with a steady glow, its shifting phases watched carefully by those who lived between the Tigris and Euphrates. To the Sumerians, the moon was more than a light in the night sky. It was the clock by which they measured life itself. From harvest to holy days, its waxing and waning became the framework of time, and within this framework, they built one of the most precise calendars of the ancient world. Archaeologists studying ununiform tablets have found lists of months that reveal the depth of this lunar system. The year was divided into 12 months, each beginning with the first visible crescent moon. Yet the Sumerians knew that 12 lunar months did not perfectly align with the solar year. To correct this, they introduced additional months at certain intervals, keeping their calendar in harmony with the seasons. This balancing act shows not only observation, but also an early grasp of mathematical adjustment. The connection between the moon and daily life was also religious. The god Nana, later known as Sin, ruled over the moon and was worshipped in the great city of his ziggurat, still rising in ruins today, was a place where priests looked upward to read the sky. By linking divine authority with lunar measurement, the calendar became both sacred and practical, a guide for farmers and a tool of power for rulers. The month names themselves carry traces of how deeply time was tied to survival. Many were connected to farming cycles from planting to harvest, showing that the calendar was not just a religious schedule, but a manual for sustaining life in a land dependent on seasonal floods. Without such precision, crops could be planted too early or harvested too late, threatening entire communities. Evidence shows that the Babylonians, inheriting Sumerian knowledge, refined the system further. By the first millennium BCE, they had established a cycle of 19 years within which 7 extra months were inserted. This cycle, now called the Metonic cycle, was also known in ancient Greece centuries later. The mystery is how such a complex and accurate correction system appeared in Mesopotamia so early, long before similar methods arose elsewhere. The astronomical diaries written on clay tablets contain daily records of the moon, noting when it rose and when it set. These diaries kept for centuries provided the data needed to refine the calendar continually. The effort required to maintain such records suggests a culture deeply invested in preserving accuracy across generations, a task that demanded not only patience but also institutional stability. The importance of the lunar calendar extended into politics. Kings often declared their reigns by referencing specific months, and contracts or trade agreements were dated according to lunar cycles. This gave the calendar a legal weight, binding society together under a single system of time that stretched across regions and dynasties. Priests played a central role in maintaining the calendar. Their duty was to declare the beginning of each month, usually by sighting the first crescent moon after sunset. This ritual decision carried great weight as it set the rhythm for festivals, sacrifices, and taxation. The dependence on priestly authority shows how timekeeping and religious power were woven tightly together. Festivals illustrate how deeply lunar rhythm shaped culture. The Akitu festival, a New Year celebration, was tied to the first month of the lunar year, and its timing linked political renewal with cosmic cycles, reinforcing the king's role as mediator between the divine and human realms. Without the calendar's precision, such events could not have carried the same weight or consistency. The Sumerians also understood the moon's influence on tides and water cycles, which mattered in a land defined by rivers. Though they may not have fully explained the mechanics, their association of the moon with water was strong enough to shape mythology and ritual. This connection gave the lunar calendar even greater authority, suggesting that the heavens directly influenced the land's lifeblood. Astronomers working in later centuries marveled at Mesopotamian precision. Greek thinkers such as Hipparchus drew upon Babylonian records to refine their own understanding of lunar motion. Without those tablets preserved by chance in libraries and archives, the continuity of astronomical knowledge might have been broken. The chain that links ancient Mesopotamia to later science runs through the moonlit sky of Sumer. Yet puzzles remain. The accuracy of their intercalation, The method of inserting extra months suggests they already knew of cycles requiring decades of observation. But no early trial and error records have been uncovered. The first surviving examples already show a high level of mastery, leaving a gap where the learning process should be. This missing trail makes the achievement appear sudden, as though the knowledge arrived whole rather than through gradual discovery. The choice of the moon as the foundation of timekeeping may also hold deeper meaning. Unlike the sun, whose changes are subtle day by day, the moon shifts quickly and visibly, demanding attention. Its phases are simple to observe but complex to calculate, making it a natural yet challenging guide. That the Sumerians embraced this challenge and solved it with such enduring success suggests an intellectual tradition more advanced than we often imagine for the ancient world. What survives today is a reminder of how closely ancient people lived with the sky. Every crescent moon seen from the walls of or the fields of Nippur was not just a passing sight, but the signal of a new month, a fresh count, another step in the cycle of time. Behind each simple mark pressed into clay lies a silent record of human persistence, watching, measuring, and recording the heavens. The moon continues its silent rhythm, but the mystery lingers in how the first great calendar of the ancient world emerged, already refined as though its earliest steps have been swallowed by time, the Baghdad battery precursors. When workers near Baghdad unearthed a clay jar in the 1930s, it seemed at first to be nothing more than pottery from a forgotten era. Yet inside the jar were a copper cylinder and an iron rod sealed with bitumen. The strange arrangement looked less like a vessel for storage and more like a tool with a purpose. Later experiments suggested that when filled with acidic liquid, the jar could generate a small electric charge. It became known as the Baghdad battery, and its discovery forced new questions about whether ancient people knew how to harness forces we often consider modern. So the artifact was dated to around 2,000 years ago during the Parthian or Sasanian periods, but its design hinted at deeper origins. The use of clay, copper and bitumen matched technologies already present in Mesopotamia long before this time. Some historians wondered if the battery was the result of an older tradition passed down through centuries with roots reaching back to Sumerian or Babylonian experiments. If so, the jar may have been less an invention of its time than the last trace of a much earlier craft. Bitumen itself holds a central place in Mesopotamian history. It was used to seal boats, bind bricks, and waterproof containers. Its insulating qualities would have made it perfect for constructing something like a battery. That such materials were common as early as the Sumerians to suggest that the building blocks for electrochemical devices existed long before the Parthians. The leap from sealing a jar to sealing a jar with metal parts is small yet transformative, and this leap remains unexplained. Some scholars propose that jars with copper linings could have been used for electroplating. The process would allow thin layers of precious metal to be deposited on objects, creating a sheen of wealth without the cost of solid gold or silver. Experiments in the 20th century showed that replicas of the Baghdad battery could indeed plate small objects with a thin coat of metal when filled with vinegar or grape juice. If true, it would mean that knowledge of chemistry and electricity was applied to practical arts in the ancient world. Other interpretations suggest a more symbolic use. The jars could have been religious or healing devices where mild shocks were experienced as divine or therapeutic. Electricity, invisible and mysterious, may have been understood as a spiritual force. If priests or healers controlled its use, it would explain why no widespread record of electrical knowledge has been found, as the practice could have remained confined to sacred rituals. The problem is that the historical trail is thin. Only a handful of these jars have been discovered, and their contexts are poorly recorded. Without clear archaeological layers or written descriptions, their purpose remains elusive. And what they do provide is a starting point for asking whether earlier Mesopotamian civilizations experimented with materials in ways that later generations only partially preserved. Hints of precursors appear in unexpected places. Ancient Mesopotamian texts describe shining temples and objects imbued with power, though these may be metaphor rather than literal references. Still, when combined with the physical reality of the jars, such descriptions fuel speculation that electricity, however faintly, was once part of sacred or technical practice. The mastery of metallurgy in Mesopotamia supports the possibility. Copper, bronze and iron were widely used and carefully worked. The skills required to shape thin copper sheets or rods for inclusion in jars were well within their reach. What remains unexplained is the spark of insight, and the recognition that metals, liquids, and sealed containers could create reactions beyond their ordinary uses. That insight appears abruptly in the Baghdad finds, as if an old idea had resurfaced without its original context. Historians caution against overstating the evidence. The jars could have been simple storage containers. Their copper cylinders are intended for preservation of scrolls or small objects rather than for conducting electricity. Yet the replication of electrical effects in experiments keeps the mystery alive. Few artifacts have inspired as much debate because their design straddles the boundary between the ordinary and the impossible. If the jars were indeed the last expression of a much older knowledge, the true beginnings may lie buried beneath layers of Mesopotamian ruins still unexplored. The constant rebuilding of cities like Babylon and Nineveh has left complex archaeological records where early traces may be hidden. Until discoveries emerge, the Baghdad battery stands alone. Its silence is as intriguing as its potential. What makes the idea of precursors compelling is the continuity of Mesopotamian ingenuity. From ununiform writing to complex calendars, the region produced innovations that seem to appear fully formed. The battery jars may belong to this same pattern. Sudden appearances of sophisticated ideas whose early stages are invisible. Whether through loss of records, secrecy of use, or sheer chance, the chain of development has been broken, leaving only fragments to puzzle over. Today, the surviving Baghdad battery is housed in the Iraq Museum, a small object overshadowed by grander relics of kings and gods. Visitors who pause before it see little more than a jar, yet in its plainness lies the possibility of untold histories. It is a reminder that not all mysteries are carved in stone or written on tablets. Some are hidden in clay, sealed with bitumen, and waiting for an answer. The faint potential of electricity from an ancient jar suggests that knowledge once flickered in Mesopotamia that we still do not fully understand, like a spark glimpsed briefly before being swallowed by the dark. Sumerian mathematics. On a clay tablet no larger than a hand, tiny wedge-shaped marks hold answers to problems written nearly 4,000 years ago. These tablets, baked hard by accident or design, carry traces of an ancient classroom where students once copied equations under the watchful eye of a teacher. They do not look like lessons as we know them. Yet within the numbers lies a system that shaped much of the world's future. The Sumerians of Mesopotamia built their mathematics around a base 60 system, unlike the base 10 that dominates today. At first glance, this choice seems puzzling, but 60 holds a special strength. It can be divided evenly by many numbers, 2, 3, 4, 5, 6, and beyond. This flexibility allowed the Sumerians to express fractions with unusual ease, something that still influences how we divide time into 60 minutes or a circle into 360 degrees. Evidence of their mathematical reach survives in tablets such as Plimpton 322 discovered in Iraq, and now held in the Rare Book and Manuscript Library at Columbia University dated to around 1800 BCE. It lists sets of numbers that appear to be related to right-angled triangles. To many scholars, and this shows that Sumerians understood principles of geometry long before Greek thinkers like Pythagoras gave them formal names. The tablet suggests they solved problems of land measurement and construction with knowledge that feels surprisingly advanced. Practical needs drove much of this progress. The fertile but shifting lands of Mesopotamia demanded careful management of fields and canals. Measuring plots, dividing harvests, and recording debts all required accurate calculation. Mathematics became not just a tool for scribes, but a necessity for farmers, builders, and traders. In this way, numbers were woven into the rhythm of daily life. Far from abstract theory, the scribal schools known as Dubus trained young men to master this demanding system. Students copied long lists of multiplication tables, reciprocal tables, and complex word problems. Some exercises included riddles about grain, bricks, or journeys, showing how math connected to ordinary work. The precision expected of students reveals how deeply their society valued exact record-keeping, a foundation for both administration and commerce. The use of reciprocals is one of the most striking aspects of Sumerian calculation. Instead of dividing as we do, they often multiply by the reciprocal, a method that works seamlessly in a base 60 system. This practice points to an understanding of operations that was both clever and efficient. It also explains the long tables of reciprocals carved into tablets, which must have served as reference books for students and professionals alike. Astronomy further stretched their mathematical skills. Observing the movement of the moon and planets required careful recording of cycles, which in turn demanded precise arithmetic. The Sumerians linked their sexdecimal system to the heavens, using it to track months, predict eclipses and regulate calendars. Later Babylonian astronomers inherited and expanded these methods, creating records that still astonish modern researchers. Commerce also pressed mathematics into new shapes. Merchants tracked goods that flowed along the Tigris and Euphrates, from grain to textiles to metals. Contracts, often inscribed on tablets, show calculations of weight, interest, and exchange. Without strong numerical methods, such agreements could not have been enforced. Numbers became a language of trust, binding trade across the region. Despite the practicality, the elegance of their system cannot be ignored. The decision to base counting on 60 may have begun with simple hand gestures, fingers and sections of knuckles, but it grew into a framework that could stretch to the stars. From simple tallies of sheep to predictions of celestial events, the system adapted to every scale. This adaptability hints at a culture that saw order not just in markets or fields, but in the structure of the cosmos itself. The survival of these tablets feels almost accidental. Many were discarded, broken, or left behind when cities fell. Fires that destroyed libraries sometimes preserved clay records by baking them harder. What remains is only a fraction of what once existed. Yet even these fragments reveal a world where mathematics was central to power and survival. They remind us that advanced thought does not always arrive with fanfare, but may be pressed quietly into clay by unknown hands. The question that lingers is how far their understanding reaches. Did they glimpse theories we now consider modern, or were they simply resourceful in solving the needs of their time? The neat rows of numbers suggest patterns noticed and pursued, but without written explanations, the intent behind them is left to interpretation. Scholars debate whether the creators of tablets like Plimpton 322 aimed at abstract mathematics or practical surveying, yet the possibility of both makes the mystery sharper. Looking at these ancient numbers is hard to escape a sense of continuity. Every time a clock ticks through 60 seconds or a compass measures a circle, echoes of Sumerian thought are present. Their system, born in fields and canals, continues to shape our daily lives in ways most never notice. It is a legacy written not in grand monuments, but in silent marks pressed into clay, holding secrets that are still not fully understood. In the ordered rows of wedges carved thousands of years ago, one can almost see a shadow of minds reaching beyond necessity, as if numbers themselves whispered truths waiting to be uncovered. Mysterious cylinder seals. In museum cases around the world, small stones, no bigger than a finger, rest quietly under glass. They do not shine like gold or draw the eye like a statue. Yet when rolled across wet clay, they reveal entire worlds. These are the cylinder seals of ancient Mesopotamia, carved with patterns so fine that even today it is hard to believe they were made by hand more than 4,000 years ago. The seals were more than decorative objects. Each one carried a repeating design, and when pressed into clay, it created a continuous image that worked like a signature. Officials used them to mark documents, seal containers, and secure storms. In a society where trust depended on record keeping, a seal was as personal and powerful as a written name. Losing one meant losing the ability to prove identity. The craftsmanship behind them remains one of their greatest mysteries. Many were carved from hard stones like hematite or lapis lazuli. Materials are difficult to shape even with modern tools, yet Sumerian artisans achieved intricate detail, spirals, figures, animals, and entire mythological scenes on surfaces sometimes less than an inch wide. How they managed such precision without metal drills or magnifying lenses is a question still debated by researchers. But what the seals depict adds another layer of intrigue. Scenes often show Sukids seated on thrones, celestial symbols like stars or crescent moons, or strange winged beings that have no clear explanation. Some images appear to combine human and animal traits, suggesting myths that are only partly understood today. The meaning behind many of these symbols has been lost, leaving the seals open to endless interpretation. Cylinder seals also raise questions about the spread of ideas across Mesopotamia. They have been found not only in Sumerian cities like Ur and Uruk, but also in later Ardean and Babylonian contexts. Some travelled far beyond the rivers of Mesopotamia, reaching Anatolia and even the Indus Valley. The seals seem to have carried not just ownership marks, but also cultural messages suggesting networks of trade and influence that were wider than many had imagined. The variety of styles points to shifting purposes. Some seals were clearly tied to official administration, stamped onto contracts or storage jars. Others seem more personal, worn as amulets or jewellery. Still others display elaborate myths in miniature, telling stories that may have served as reminders of cosmic order or divine protection. Each seal, therefore, carried both practical function and symbolic weight. Discoveries in royal tombs show how highly these objects were valued. At the site of her, excavations uncovered cylinder seals buried with kings, queens, and attendants. Placed alongside gold jewellery and precious instruments, the seals held enough importance to follow their owners into the afterlife. To these Sumerians, they were not mere tools, but possessions that link the earthly world with divine authority. Modern analysis has tried to unlock the methods used to carve these tiny masterpieces. Microscopic studies suggest that artisans employ drills tipped with harder materials, perhaps even using abrasives like quartz sand to cut into stone. Yet even with these techniques, the smoothness and depth of the carvings remain difficult to match. Some designs are so precise that they seem almost mechanical, sparking speculation about lost tools or forgotten skills. Beyond their technical marvel, the seals preserve pieces of mythology otherwise unknown. While ununiform tablets give written accounts, the seals show gods in action interacting with humans, animals, and symbols. A single rolling could compress a narrative into a strip of images, and offering a kind of ancient storyboard. Scholars often debate whether certain recurring figures represent known gods or deities whose names are now lost. There is also the matter of celestial imagery. Many seals feature star clusters, crescent moons, and symbols that resemble constellations. The accuracy of these depictions raises questions about how much the Sumerians observed in the night sky and how they linked it to their myths. Some argue that the seals record astronomical events, while others see them as purely symbolic. The line between religion and science so clear to us today may not have existed in their world. The seals also connect to the development of writing itself. Before the widespread use of ununiform, impressions in clay helped to record ownership and exchange. Cylinder seals seem to stand between images and words, thus bridging the gap between art and administration. Their rolling impressions created repeated patterns that foreshadowed the lines of text that would soon dominate Mesopotamian records. Every seal is unique, yet together they form a language of symbols that we cannot fully read. The gods they show, the rituals they suggest, and the myths they hint at leave us with fragments rather than full stories. For archaeologists, deciphering these fragments is like listening through a broken instrument. Parts of the melody remain, but much of the song is gone. Still, their survival offers a rare glimpse of daily and divine life in this earliest cities. Unlike monuments that crumble or texts that burn, seals were small, portable, and durable. They slipped into graves, lay hidden in ruins, and survived fires that destroyed palaces. That their endurance means that voices from thousands of years ago still whisper through their carved surfaces. If only we could fully understand them. To study a cylinder seal is to confront a paradox, an object so small it can be held in the palm, yet vast in the mysteries it contains. Knowledge of the precession of the equinoxes. On quiet nights in southern Mesopotamia, when the rivers slowed and the sky turned black, Sumerian observers lifted their eyes upward. The stars above were not background decorations to them. They were maps, guides, and signs of order in a world ruled by the unpredictable floods of the Tigris and Euphrates. But hidden within the slowdowns of the heavens lies a cycle so vast that it takes nearly 26,000 years to complete, the precession of the equinoxes. The question that troubles historians is whether the Sumerians, the thousands of years before the Greeks recorded it, already knew of this grand celestial shift. The precession itself is the gradual wobble of Earth's axis, which causes the position of the stars to change very slowly over centuries. To detect it requires watching the sky across many generations, noting that the constellations marking the spring equinox slowly drift. Western history credits the discovery to Hipparchus, a Greek astronomer working in the 2nd century BCE. Yet hints in Mesopotamian records suggest that knowledge of this slow cycle may have existed long before his time. Ununiform tablets preserve lists of star names and astronomical patterns recorded in Babylon and earlier Sumerian cities. Among these, scholars have pointed to the so-called Moldot Ain tablets, a collection of texts that detail the paths of stars to the length of days and celestial risings. Though compiled later, many of these records draw upon observations said to stretch back into Sumerian times. The consistency and precision of these texts raise the puzzle of how such long cycles were tracked without an awareness of precision. In several seals and inscriptions, constellations are represented in ways that fail to match their true locations in the sky during the period of creation. For example, star symbols paired with figures of bulls, lions, or scorpions suggest associations with Taurus, Leo, and Scorpio. Yet these constellations would only have aligned with equinoxes or solstices in far earlier epochs thousands of years before. If these symbols were indeed astronomical markers, they may hint that the Sumerians encoded memories of a shifting sky, and the link between gods and stars further complicates the mystery. Sumerian deities were often paired with celestial bodies, Inanna with Venus, Utu with the sun, Nanna with the moon. Some myths describe the heavens as realms that undergo cycles of renewal and decline, themes that echo the slow turning of the equinoxes. While myths cannot be treated as direct science, they sometimes preserve fragments of real observation disguised as the story. The question remains whether the procession was one of those fragments. Archaeologists have long debated the purpose of ziggurats, the massive step temples that rose above Mesopotamian cities. While religious function is clear, their height and alignment with cardinal direction suggest that they also served as viewing platforms. From such towers, priests could watch the horizon night after night, recording the rising and setting of stars. Over centuries, even small deviations would have become clear. It is within this context that claims of early awareness of precession gain weight. One of the strongest pieces of circumstantial evidence lies in the Sumerians' obsession with cosmic cycles. Their calendars linked months to solar years, their rituals tied harvests to stellar risings, and their myths spoke of ages ruled by different gods. Such preoccupation with cycles implies not just an interest in short-term rhythms, but perhaps an awareness of longer, subtler changes that only reveal themselves over millennia. Some modern researchers argue that later Babylonian astronomy inherited more from Sumer than is often credited. Babylonian scholars in the 1st millennium BCE produced detailed ephemerides and tables predicting celestial movements with accuracy. These works, they claimed, were built upon earlier archives of observation stretching back centuries. If those records carried traces of precision, then the roots of the discovery may indeed reach into Sumerian soil. Still, one must proceed with caution. No surviving Sumerian tablet explicitly names precession, nor does any text describe Earth's axis or its slow wobble. The evidence lies in hints, symbols, and alignments that resist definitive interpretation. Scholars remain divided. Some see ancient knowledge of long cycles, others argue for coincidence or mythic symbolism. What makes the matter haunting is not certainty, but the persistence of patterns that seem too exact to ignore. The cultural importance of equinoxes and solstices strengthens the puzzle, and these turning points of the year were celebrated with festivals, offerings, and rituals. If the equinox marker, the point where day and night were equal, drifted slightly over centuries, would Sumerian observers not have noticed? Their reliance on precision for agriculture and ritual timing suggests they must have tracked these shifts closely, perhaps closer than history currently credits. Astronomy in Mesopotamia was never purely scientific in the modern sense. Observations were tied to omens, predictions of royal fate, and the will of the gods. But practical accuracy was still crucial. If records of eclipses or planetary risings extended back far enough, patterns would emerge that could only be explained by acknowledging a hidden cycle. Whether they described it as a precession or couched it in mythic language, the effect may have been the same. The sentence of the surviving text only deepens the enigma. Clay tablets are fragile, and what survives is a fraction of what once existed. Fires, floods, and time itself have erased vast portions of the record. Somewhere in those missing archives could have been a description, however veiled, of the shifting heavens that we now call precession. Thus, the question hangs in the air, unresolved yet enticing. Did the Sumerians beneath those familiar stars perceive that the heavens were quietly sliding forward with the passage of ages? The Flood Tablet. In 1872, a quiet buzz filled a room at the British Museum as George Smith, a self-taught Assyriologist, leaned over a clay fragment. Before him were uniform signs that told a story older than the Bible, yet strangely familiar. And as he read aloud the tale of a great flood and a man chosen to build a boat, the scholars present realized they were listening to a Mesopotamian version of Noah's Ark. That tablet, broken but legible, would become known as the Flood Tablet. The fragment came from Nineveh, the capital of the Assyrian king Ashurbanipal, whose library had been buried since the 7th century BCE. excavated by Austin Henry Leard and his team in the mid-9th century. The library yielded thousands of tablets. Among them was Tablet Phypon of the Epic of Gilgamesh, written in Akkadian but preserving myths that stretched back to Sumer. It told of Utnapishtim, a man warned by the gods to construct a vessel to survive a flood meant to wipe out humanity. The parallels with the biblical book of Genesis are striking. Utnapishtim's ark was sealed with pitch, but filled with animals and a bird to search for dry land. When the waters receded, the vessel came to rest on a mountain, and a sacrifice was made in thanks. Such details mirrored the story of Noah. Yet, the Mesopotamian version predated the Hebrew text by centuries. This raised questions that scholars still debate. Did both traditions stem from the same historical memory, or did one borrow from the other? What sets the Flood Tablet apart is not only its similarity to biblical stories, but also the possibility that it records an actual event. Mesopotamia was a land of rivers that regularly burst their banks. Sudden floods could sweep across entire regions, destroying fields and villages. Some researchers believe that the myth may preserve memories of a particularly catastrophic flood, magnified into legend through generations of retelling. Geological evidence adds weight to this idea. In the 1920s, archaeologist Leonard Woolley excavated a Dur and found a deep layer of riverborne silt beneath the city's remains. He interpreted it as evidence of a great flood that might have inspired the stories. Later studies showed that floods in Mesopotamia were frequent but uneven, affecting some areas while leaving others untouched. Whether one single event or a pattern of disasters lies behind, the myth remains unsettled. The story's endurance suggests more than a record of disaster. Within the narrative lies a moral framework. Humanity judged, gods divided, survival granted to a chosen figure. These themes echo across cultures from Mesopotamia to the Hebrew Bible to later traditions. The universality of the flood motif hints at something deeply rooted in human memory, out an ancient attempts to explain destruction and renewal through story. The literary artistry of the Flood Tablet is also notable. The tale appears within the Epic of Gilgamesh, where the hero seeks immortality. That Napishtim tells his flood story not as a separate myth, but as part of Gilgamesh's quest. In this way, the flood becomes a lesson. Eternal life belongs only to those singled out by the gods. The blending of personal struggle with cosmic disaster gives the tablet both narrative force and philosophical depth. The tablet itself, now housed in the British Museum, is incomplete. Lines are missing, words chipped away by time, yet enough survives to reconstruct the arc of the story. Scholars piece together the missing portions by comparing other fragments, some discovered later. And each new find confirmed that the flood story circulated widely across Mesopotamia, written in different dialects and copied for centuries. One of the enduring mysteries is how such stories travelled. Mesopotamia's myths influenced the cultures that succeeded it from Akkad to Babylon and beyond. The Hebrews exiled in Babylon during the 6th century BCE may have encountered the flood myth directly, adapting it into their own scripture. The possibility of cross-cultural borrowing adds another layer of complexity, showing how one ancient tablet could ripple through later civilizations. Some details of the Mesopotamian account remain unlike the biblical story. The gods in the Epic of Gilgamesh quarrel among themselves, some regretting the destruction, others fearful of losing offerings from humankind. When the flood ends, the gods gather like flies over Utnapishtim's sacrifice. These elements suggest a worldview where divine beings are flawed, emotional, and dependent, very different from the singular commanding God of the Hebrew account. The Flood Tablet forces us to confront the blurred line between myth and memory. Was it a poetic retelling of a natural disaster, an allegory for renewal, or a trace of an actual flood that terrified early civilizations? No single answer fits neatly, and that uncertainty fuels its enduring fascination. Each time the tablet's wedge-shaped marks are studied under museum lights, the same question returns. How much of this story was imagination, and how much was a record of something our ancestors truly lived through? The king list and impossible reigns. The stone surface bears names in tight, deliberate script, and each wedge pressed into the clay by a scribe who likely believed he was preserving truth. It is called the Sumerian king list, and at first glance it looks like a straightforward record of rulers. Yet as the eyes move down the columns, the list begins to slip into the realm of the impossible, claiming reigns that stretched for thousands of years and dynasties said to have ruled before a great flood swept over the land. The king list was not a single document, but a tradition copied and recopied across Mesopotamia. The most complete version, found at Lhasa and now housed in the Asholian Museum, contains a sequence of kings ruling from different cities such as Eridu, Kish, Ur and Akkad. Unlike simple chronicles of events, the text presents an ordered line of succession, as if kingship itself passed from city to city by divine command. The tone is not neutral, it carries a weight of authority, as though it were meant to bind history and myth together in one chain. What unsettles modern readers is the length of the rule assigned to the earliest monarchs. In the pre-flood section, the list claims that kings reigned for tens of thousands of years. The first ruler, Alolim of Eridu, is said to have ruled for 28,800 years, followed by Algar with 36,000. Other names stretch on similarly until the flood brings that era to an end. These figures do not fit with human lifespans, even when viewed as symbolic or exaggerated, leaving open the question of why such numbers were chosen. After the flood, the list changes tone, though it does not shed its strangeness. Reigns become shorter yet remain far beyond plausibility. Some rulers are credited with centuries on the throne, but while others ruled for decades more in line with historical expectations, the alternation between fantasy and realism gives the list a fractured quality, as though it preserves fragments of memory layered with invention. Archaeologists began to piece together the king list from fragments discovered in the early 20th century. When scholars compared copies from Nepa, Lhasa and other sites, they found remarkable consistency in names and structure, even where the reign length seemed fantastic. This suggested that the list was not a random tale, but a carefully transmitted text repeated across generations. Its endurance raises questions about the purpose it served in Mesopotamian culture. One view holds that the king list was propaganda, by linking rulers in one unbroken sequence, and it presented the idea that all legitimate authority flowed from a divine source. Even when cities fought for dominance, the text implied continuity, as though kingship was never lost, only transferred. This could have reinforced the power of later rulers who wished to anchor themselves in a tradition reaching back to the world before the flood. Another possibility is that the extreme numbers were symbolic. Some researchers suggest that the immense reigns before the flood were meant to mark a mythical age distinct from ordinary time. In this reading, the figures did not describe real years, but cosmic cycles or numerological patterns meaningful to Sumerian thought. Yet even if symbolic, the numbers chosen remain curious, and their repetition across copies shows they were not accidental scribal flourishes. The king list also intersects with archaeology in puzzling ways. Some names on the list, such as Emma Baragasi of Kish, have been confirmed through inscriptions outside the text, grounding parts of the sequence in verifiable history. This mixture of the real and the impossible blurs the boundary between myth and record, leaving scholars to debate which layers preserve authentic memory and which belong to legend. The flood, dividing the list into two eras, deepens the mystery. By placing an enormous deluge at the centre of political chronology, the text suggests that kingship survived even when humanity itself nearly perished. The image echoes the flood tablet of the Epic of Gilgamesh, but here it functions less as myth and more as a dividing line in history. Why Sumerian scribes chose to structure their political record around such an event remains one of the most debated aspects of the list. Modern readers approach the text with scientific skepticism, but for ancient Mesopotamians, it may have been something more than history. It could have served as a reminder of divine order, a cosmic chart showing how power was woven into the fabric of existence. By reading the names aloud, scribes might have reinforced the belief that every ruler stood within a sacred lineage, whether reigning for 30 years or 30,000. Even today, the king list resists simple explanation. It is part historical document, part theological statement, part riddle carved into clay. To read it is to step into a space where fact and imagination are inseparable, where kings are both men of flesh and figures of myth. But what remains is the mystery. Did the impossible reigns preserve a coded echo of lost ages? Or were they only the invention of scribes determined to stretch time into eternity? The ziggurat's mysterious engineering. The desert sun rises over flat plains, but one structure catches the light before anything else. Its stairways climb toward the sky, tier after tier, like a mountain built by human hands. This is the ziggurat, one of the most striking and enigmatic forms of ancient architecture in Mesopotamia. Though many lie in ruins today, their remains still provoke questions about how such massive structures were raised in a land with limited stone and almost no timber. Unlike temples hidden within city walls, ziggurats towered over the settlements around them, built on raised platforms and ascending in layers. They seem designed to connect heaven and earth. The best preserved, the ziggurat of once rose in 3 vast stages. Its base measured about 64 meters on each side, and even in its ruined state it commands the landscape. To build something so immense more than 4,000 years ago required a level of planning and skill that is still difficult to imagine. The core of a ziggurat was usually made of sun-dried mud bricks, materials easily produced from the clay-rich soil of the region. Yet this choice raises a puzzle. Mud brick erodes quickly when exposed to rain, and Mesopotamia's seasonal storms could wear down walls in a few years. To protect the core, builders encased it in fired bricks, often sealed with bitumen, a natural tar that acted as waterproofing. This combination gave the structures both strength and resilience, but it also required massive coordination to produce and transport countless bricks. Itself is a mystery in the story of ziggurats. It was collected from natural deposits along the Tigris and Euphrates rivers, then heated and applied as mortar or coating. The sticky black substance bound bricks tightly and shielded them from water. The logistics behind its use must have been complex, for vast amounts were needed to cover a single tier. Archaeologists still debate how ancient workers managed the heating, carrying and layering of this material on such a large scale without modern tools. The ziggurat was not a hollow monument, but part of a larger sacred complex. At its summit stood a shrine, likely accessible only to priests or royalty. Reaching this upper sanctuary involved climbing staircases that rose along the sides or sometimes spiraled around the structure. The physical act of ascending would have created a sense of separation from the world below, an experience that may have been as important as the rituals performed at the top, but little direct evidence survives of what took place inside those shrines, leaving their function wrapped in silence. The scale of labour behind these projects is staggering. Tens of thousands of bricks had to be moulded, dried, or fired for a single layer. Workers hauled them into place under intense heat, often with no mechanical aid beyond sledges and ropes, while researchers suggest that entire city populations were mobilised with seasonal building campaigns carried out year after year. So that the organisation required for such feats points to a level of social control and planning that rivaled later empires. Even more curious are the alignments of certain ziggurats. Excavations have revealed that many were oriented with remarkable precision to the cardinal directions. The ziggurat of Akkar occurred near Baghdad, for example, faces almost exactly north, south, east and west. Whether this was symbolic, practical or astronomical remains an open question. The possibility that the builders used the stars to guide construction adds a layer of sophistication that we're only beginning to understand. As centuries passed, ziggurats were rebuilt and expanded. Each new ruler often added his own layer, enlarging the base or raising the summit higher. In some cases, older bricks were left inside as the outer shells grew, creating a kind of layered archive of human effort. This practice suggests that the structures were not just functional temples, but living monuments continuously reshaped to reflect shifting power and devotion. The ruins we see today are fragments of what once were brightly decorated towers. Archaeological traces suggest that walls may have been painted in vivid colours with blues, reds and whites glistening under the sun. Glazed bricks, some adorned with simple designs, have been found around former ziggurat sites. The visual impact of a towering multicoloured pyramid rising from the flat plain must have been overwhelming. Yet time has stripped most of these details away. One of the great unsolved questions is how long these structures were meant to last. The choice of mud brick for the core seems temporary compared to stone, and yet the repeated reconstruction suggests a cycle of renewal was part of their design. Instead of permanence, the builders may have accepted decay as natural, with each generation tasked to restore the connection between the heavens and their city. This philosophy of constant rebuilding leaves us uncertain whether we are looking at remnants of the first towers or the 10th. The engineering of the ziggurats remains both practical and mysterious. On one hand, we can trace the steps of brickmaking, waterproofing and stairway construction. On the other hand, we still do not know how the ancient Mesopotamians achieved such precision and scale without advanced tools. Their ability to marshal labour, align structures, and create monuments that endured millennia speaks of knowledge that is difficult to measure by modern standards. The ziggurats stand today as silent shells of their former glory, but the secrets of how they were built and what exactly they represented continue to elude us. Medical knowledge ahead of its time. From the ground of Mesopotamia emerges a clay tablet that bears not just the marks of commerce or decrees of rulers. Scratched into its surface are words describing fevers, wounds, and remedies. These records show that long before Greek physicians walked through temples of healing, the Sumerians were already writing down symptoms and treatments, creating one of the world's earliest medical traditions. Dating back to about 2100 BCE, the tablets that remain show a striking mixture of careful observation and sacred ritual. Illness was often described as the work of spirits, yet at the same time symptoms were listed in detail, suggesting that healers paid close attention to the human body. A patient might be said to suffer from the hand of a god, but the tablets still included careful notes about the pulse, the skin, or the colour of discharge. This dual approach makes their writings both mystical and practical. Among the earliest known collections is a set of tablets from Nippa, one of Sumer's major cities. These texts outline treatments for digestive problems, infections, and injuries. Some remedies call for herbs mixed with beer or wine, others for pecuses applied directly to wounds. The choice of ingredients suggests experimentation as healers learned which plants soothed pain or reduced swelling. Such records indicate that Sumerian medicine was more than ritual. It contained seeds of rational practice. The use of natural materials shows an awareness of their environment that goes beyond simple survival. Plants like willow, known today to contain salicylic acid, appear in some prescriptions. Mineral substances including salt and sulfur also found their way into treatments. Whether by accident or careful observation, the Sumerians tapped into chemical properties that later civilizations would rediscover centuries. Healers were not limited to herbs and minerals. They also used surgery on a basic level. Clay models and texts point to procedures involving draining abscesses or stitching wounds. While there is no clear evidence of advanced internal surgery, the presence of sharp tools and controlled methods of cleaning wounds suggests that they recognized the dangers of infection. So the ability to open the skin and attempt repair shows remarkable courage and skill for such an early time. These practices were carried out by individuals often referred to as ASU, a term that roughly translates to physician. They worked alongside ship exorcists who performed rituals meant to drive out malevolent forces. Together, they represent two sides of Sumerian healing, one rooted in material treatments, the other in spiritual acts. Instead of being in conflict, the two roles often overlapped with a single healer, able to prescribe both chants and salves. This cooperation created a holistic system blending faith with science. Though compiled at a later time, the ununiform tablets uncovered in Ashurbanipal's library at Nineveh safeguard many Sumerian traditions. And these texts show medical descriptions so precise that scholars today can identify diseases such as epilepsy, pneumonia, or even strokes. For a society without microscopes or advanced tools, the accuracy is striking. They recorded patterns of recurring symptoms, building a foundation of knowledge that anticipated clinical observation in modern medicine. Even more intriguing are the diagnostic texts. Instead of simply listing cures, some tablets guide the healer through a process of examining the patient. The colour of the eyes, the sound of the cough, or the condition of the tongue could lead to different judgments. These writings demonstrate a systematic attempt to understand cause and effect, rather than relying solely on divine explanations. While many treatments may seem primitive now, that their combination of ritual and observation had unexpected benefits. Incantations, though not medicinal in a chemical sense, could calm patients and provide reassurance. Herbal remedies may have delivered real physiological effects, easing pain or reducing fever. Together, they created a therapeutic experience that addressed both body and mind, an approach not unlike some modern holistic methods. The role of the moon and stars in Sumerian medicine also adds another layer of complexity. Certain treatments were timed with lunar phases, and healers believed that celestial cycles influenced the outcome of illness. While these connections were spiritual in nature, they also reflect careful tracking of time and its relation to human health. That this blending of astronomy and medicine suggests a worldview in which the cosmos and the body were deeply intertwined. Evidence of organized training further shows the seriousness with which medicine was pursued. Tablets sometimes include instructions written in a way that suggests they were copied by apprentices. These records may have been used in schools where future physicians learned their craft. If so, then medicine was not only practiced but also systematically taught, ensuring that knowledge could be passed down across generations. The endurance of these medical traditions can be traced in later Mesopotamian cultures. Babylonians and Assyrians inherited much of Sumerian healing knowledge, expanding and refining it over centuries. Some remedies even found echoes in Greek texts, though raising the possibility that fragments of Sumerian practice travelled across cultures influencing the roots of Western medicine. And still the secrets remain. How much of their knowledge was based on trial and error? And how much was guided by a deeper understanding of the body? Did the use of specific herbs come from generations of careful testing, or were they discovered by chance? Archaeologists and historians continue to sift through broken tablets in search of answers, but the full scope of Sumerian medical knowledge may never be recovered. What is certain is that these ancient healers were not simple mystics, but observers, experimenters and recorders. Their work hints at a level of sophistication that challenges our assumptions about what early civilizations could achieve. When we look at their tablets, what we see the beginnings of medicine not as a distant dream, but as a practice already alive thousands of years ago. The fragile clay records may be cracked and incomplete, yet they leave behind a question that lingers in silence. How did the Sumerians come so close to modern medicine in a world so far removed from our own? Metallurgy and earthly Mesopotamia. At first glance, the flat plains of Mesopotamia seemed like an unlikely birthplace for metalwork. The land between the Tigris and Euphrates rivers was rich in clay and silt, but poor in ore. And yet, some of the earliest evidence of metal use in human history comes from this region. From simple copper pins to intricate bronze tools, the remains found in ancient cities show that the Sumerians had a command of metallurgy that seems far ahead of what their environment should have allowed. The earliest use of copper in Mesopotamia dates to the 4th millennium BCE, a time when most of the world still relied on stone. Archaeologists at sites like Uruk have uncovered small copper objects, including chisels and walls that suggest more than casual use. These were not accidental creations, but carefully made tools shaped through a process of heating and hammering. The very presence of copper in such quantities raises questions, since the region itself had no major copper deposits. To understand how this metal reached Mesopotamia, historians have traced trade routes stretching far beyond the rivers. Sources point to Oman, Anatolia and Iran as possible suppliers, meaning the Sumerians depended on networks that crossed deserts and mountains. Moving raw ore across such distances would have required coordination and planning, suggesting that metallurgy was not a luxury but a central part of early Mesopotamian life. By the 3rd millennium BCE, the technology had advanced from simple copper tools to alloys like bronze, created by mixing copper with tin. This step marked a major leap, as bronze was harder and more durable than copper alone. Yet tin is even rarer than copper in the Mesopotamian landscape. Scholars believe it was imported from places as far as Central Asia or the Iranian plateau, but no one has been able to pinpoint the exact source. The mystery of where the tin came from remains one of the great unanswered questions of early metallurgy. Excavations at Lagash and Nippur reveal that bronze was used for more than weapons and tools. Jewelry, vessels and ritual objects show that metallurgy entered both daily life and religious practice. As small figurines made of bronze buried in temple foundations suggest that metal carried symbolic weight. It was not just a material of utility, but of meaning, a substance that connected the human and the divine. The methods used to work these metals are equally puzzling. Texts and archaeological remains show evidence of smelting, where ore is heated to separate the metal from the stone. Furnaces, slag heaps and moulds uncovered in ancient workshops suggest a complex process that required control over temperature and airflow. The scale of these operations indicates specialized knowledge passed down and guarded by skilled craftsmen who formed a distinct class within society. One of the striking discoveries comes from Tel Osim, where a cache of bronze statues dating to around 2900 BCE was found. The figures preserved in remarkable detail show that casting techniques were already highly developed. They were made using lost wax casting, a method that requires precision and planning. Such sophistication at such an early date raises the question of how quickly metallurgy developed in Mesopotamia and whether outside influences played a role. The connection between metallurgy and power is also worth noting. Kings and temple leaders controlled workshops and directed the flow of metal goods. Inscriptions from rulers like Guda of Lagash described the acquisition of copper and the commissioning of bronze statues for temples. Metal became a symbol of authority, both earthly and divine. To hold control over metal was to hold control over society itself. Despite this importance, little is fully understood about how mythologists achieved their results. For example, evidence shows that the Mesopotamians could create arsenical bronze, a copper alloy hardened with arsenic. This requires both knowledge and risk, as arsenic fumes are highly toxic. Whether the process was intentional or the byproduct of certain ores is still debated. Either way, the result gave them stronger tools centuries before the widespread use of tin bronze. Another puzzle lies in the purity of their metal objects. Tests on artifacts reveal high levels of refinement, suggesting that smelters could control impurities. Achieving this would have demanded a close understanding of all sources and furnace design. Yet, there are no surviving written manuals describing the process. What we know comes only from the artifacts themselves, which seem to speak of a technical skill not fully explained by the fragments of evidence left behind. The scale of production is another point of wonder. Thousands of metal items have been found in burial sites, temples, and city ruins. This volume indicates not occasional use, but an industry, one that consumed vast amounts of imported ore. It required not only skilled workers but also organised trade, storage, and distribution. The very existence of this system suggests a society deeply committed to metallurgy, one that placed it at the heart of its growth. When compared to neighbouring regions, Mesopotamian metallurgy stands out. Egypt developed its own traditions, as did the Indus Valley, but the speed and scale of Mesopotamia's progress are unusual. In a land without natural metal resources, the rise of such an advanced craft seems almost paradoxical. It raises the possibility that Mesopotamian smiths held techniques or knowledge now lost to time, methods that allowed them to work with limited supplies yet achieve remarkable results. The ruins of their workshops, the sag scattered across ancient floors, and the gleam of artifacts in museum cases all point to a people who mastered fire and stone to reshape their world. Yet the full story of how they did so remains hidden. The origins of their metals, the secrets of their furnaces, and the choices that guided their craft lie beyond what the surviving record can tell us. The silence of the past leaves us to wonder how a land so poor in ore became the cradle of one of the world's first great metallurgical traditions, the strange case of Nibiru. The word Nibiru first appears not in myths of destruction, but in the careful records of Babylonian astronomers on ancient clay tablets written in ununiform. Nibiru is mentioned as part of star lists and planetary descriptions. To the scribes who wrote them, the name carried meaning, but what exactly it meant has left modern scholars with a puzzle that refuses to settle into one clear answer. The earliest reference comes from text linked to the god Marduk. In the Babylonian creation epic, the Enuma Elish, Nibiru is described as a star or heavenly marker associated with Marduk's role in ordering the cosmos. The text portrays it as a fixed point of crossing, a place where the paths of other bodies align. This is not a casual mention, but a central part of how Babylonians explain the structure of the heavens. As later astronomical tablets complicate the picture. In the Mulatapan series, which dates to the 1st millennium BCE, Nibiru is sometimes identified with the planet Jupiter. In other passages, it appears to stand for Mercury, or even a point connected to the equinox. The shifting identity has led to debate over whether Nibiru was meant as a specific planet or as a broader concept for a position in the sky. Each interpretation changes the meaning of the word and leaves space for uncertainty. The confusion grows when one considers how carefully Mesopotamian scholars observed the skies. They tracked planetary movements with such precision that later Greek astronomy built upon their records. For these observers to use a term that does not match a single fixed planet is unusual, and either Nibiru referred to different bodies in different contexts, or it was a symbolic marker that modern readers are failing to interpret in the way ancient scribes intended. Part of the mystery lies in the language itself. In Akkadian, Nibiri can mean crossing or point of transition. That definition seems to fit the descriptions of it as a boundary where stars or planets cross paths. Yet it does not explain why the term would be linked so strongly to Marduk, or why it shifted between planets in different lists. The ambiguity of the word has allowed many different explanations to flourish. In the 20th century, the word Nibiru escaped the realm of academic debate and entered popular imagination. Authors such as Zecharia Sitchin claim that Nibiru was not just a star or a planet in ancient texts, but a massive hidden world that followed a long orbit around the sun. His book suggested it was the home of advanced beings who visited Earth in distant times. While archaeologists and historians reject these ideas as speculation, the lack of a single clear definition of Nibiru has given such theories room to spread. However, within the clay tablets, a subtler story comes to light. They show that Mesopotamian astronomers used flexible systems of naming. A single star could carry multiple titles depending on its seasonal position, religious role, or alignment with a calendar. Nibiru may have been one of these shifting names, applied not to one planet forever, but to the celestial body that marked a crossing at a given time. This explanation, while logical, still leaves room for uncertainty since not all references fit neatly into this model. Another layer of intrigue is added by the fact that Nibiru appears in both religious and scientific texts. In myth, it is bound to Marduk's triumph and cosmic order. In astronomical lists, it appears alongside calculations and observations. The blending of divine symbolism and careful measurement means the word sits at the intersection of belief and science, and it is difficult for modern readers to separate one from the other. The silence of missing records deepens the enigma. Many of the tablets that might have explained how Nibiru was understood in practice have been lost. Excavations at Nineveh, Babylon, uncovered fragments, but not a complete series. What survives is partial, filled with gaps that make certainty impossible. And each new fragment that appears often raises as many questions as it answers. Even so, the persistence of the name across centuries is striking. From the Enumeralish to the late astronomical texts, Nibiru remained part of the Mesopotamian vocabulary for the heavens. The fact that it endured through so many shifts in language and empire suggests that it held a meaning considered too important to discard, even if that meaning was not fixed. Modern astronomers dismiss the idea of a hidden planet tied to the ancient word, yet they too have revived discussions about unseen worlds at the edge of the solar system. The search for Planet 9, a theoretical giant far beyond Neptune, has nothing to do with Babylonian tablets, but the coincidence of language and mystery has kept Nibiru in public conversations. An ancient ambiguity has found new life in modern speculation. At the core of this case lies the challenge of translation. Words carved into clay thousands of years ago cannot explain themselves. Scholars can compare, debate, and suggest, but the original voices that spoke of Nibiru are gone. Whether it was Jupiter shining bright in the night, a point where the heavens were thought to turn, or something else entirely, the true meaning remains elusive. What survives is a single word carrying both the weight of ancient belief and the burden of modern imagination, leaving us to wonder what the Babylonians truly saw when they looked to the sky and called it Nibiru. The Epic of Gilgamesh. The fragments of a story once hidden in clay now speak with a strange power. The broken tablets found in the ruins of Mesopotamian cities carry lines of poetry that together form what many consider the oldest surviving epic in the world. Through them, a king named Gilgamesh still walks, caught between the grandeur of myth and the shadow of history. The first pieces came to light in the mid-9th century when excavations at Nineveh uncovered the royal library of Ashurbanipal. Among the thousands of cuneiform tablets retrieved were texts that when pieced together revealed a continuous narrative. Scholars working on translation soon realized they were holding an ancient masterpiece filled with adventures, gods, and profound reflections on life and death. At the heart of the story stands Gilgamesh, king of Uruk. The epic paints him as 2/3 divine and 1/3 mortal, a ruler of immense strength and ambition. And he is also portrayed as reckless, a leader who oppresses his people until the gods intervene. To balance his power, they create a companion named Enkidu, a wild man from the steppe whose strength equals Gilgamesh's own. Their first clash ends not in death, but in friendship, a bond that drives much of the epic's power. The two heroes embark on daring quests, seeking glory and testing the limits of their strength. One of their most famous journeys takes them into the cedar forest to confront Humbaba, the giant guardian appointed by the gods. After a fierce struggle, they defeat him, cutting down the sacred trees and bringing his head back to Uruk. This victory brings them fame, but also draws the attention of the divine, setting the stage for tragedy. When the goddess Ishtar offers herself to Gilgamesh, he rejects her with scorn, recalling the fates of her former lovers. Furious, she demands revenge. The gods send the bull of heaven to punish him. But Gilgamesh and Enkidu together strike it down. Their triumph, however, is short-lived. The gods decide that Enkidu must pay for these offences, and he soon falls ill. His slow, painful decline transforms the epic from tales of adventure into a meditational mortality. The death of Enkidu shatters Gilgamesh. Struck with grief and terror, he abandons his city and sets out on a desperate search for the secret of eternal life. His path takes him across deserts and mountains through darkness and peril until he reaches Utnap-Pishtim, the one man said to have survived the Great Flood. This figure tells Gilgamesh a story that bears striking parallels to the later account of Noah, describing how the gods once sought to destroy humanity and how a single chosen survivor built a vast boat to preserve life. Utnapishtim reveals that immortality was granted to him alone and cannot be shared. Yet he offers Gilgamesh a test. If the king can stay awake for 6 days and 7 nights, he might prove himself worthy. Gilgamesh fails, overcome by sleep almost at once. Even when Utnapishtim directs him to a plant that restores youth, the chance slips away. A serpent steals it while Gilgamesh bathes, leaving him with nothing but the bitter truth that death cannot be escaped. The epic does not end in despair, however. Gilgamesh returns to Uruk and looks upon its mighty walls, realizing that his lasting legacy will not be immortality of the flesh, but the endurance of what he built. The story closes not with triumph, but with recognition, a human understanding that achievement and memory stand where eternal life cannot. What haunts this ancient work comes as much from its voice as from its age. The themes it explores, friendship, loss, the fear of death, remain as familiar today as they were thousands of years ago. Even in fragments, the poetry speaks with urgency, reminding readers that the struggle against time and fate is as old as civilization itself. The tablets themselves carry their own mysteries. No complete copy of the epic has ever been found. Instead, scholars must rely on broken pieces from different centuries stitched together to form a rough whole. Versions differ in details, with some episodes longer or shorter, others missing entirely. Each discovery reshapes the way the story is understood, leaving the possibility that new finds could alter it once again. The survival of the epic across languages adds another layer of fascination. Written first in Sumerian tales and later compiled in Akkadian, the story evolved with the cultures that preserved it. That it endured at all is remarkable, given the fragility of clay tablets and the long centuries of war, fire, and decay that might have erased it forever. Its survival feels like a chance, as if Gilgamesh himself refused to vanish into silence. Debates continue over how much of the epic reflects historical memory. Scholars agree that a king named Gilgamesh may have ruled Uruk around the early 3rd millennium BCE. Though evidence is scarce, whether the epic preserves faint echoes of real events or transforms a distant ruler into a legendary figure is impossible to say. The line between history and myth blurs, as it so often does in the ancient world. The rediscovery of the Epic of Gilgamesh in modern times sent shockwaves through both scholarship and religion. The flood story in particular, older than the biblical account, raised questions about the transmission of myths across cultures. Yet beyond its influence, the epic endures because of its humanity. It confronts questions that remain unanswered about the limits of power, the weight of grief, and the meaning of life in the face of death. Through fragments baked in clay, an ancient voice whispers across time, reminding us that even in the earliest cities, people wondered how to face mortality and what remains when all else is lost. Unexplained maps of the stars. Long before telescopes reached the heavens, the night sky was recorded in ways that remain difficult to explain. Among the clay tablets, carvings, and fragments left by Mesopotamian civilizations are images, an inscription that seem to trace constellations with uncanny accuracy. These artifacts, fragile and incomplete, raise questions about how ancient observers could have charted patterns that appear far more advanced than the tools known to them should have allowed. One of the earliest clues lies in the ruins of Nineveh, where thousands of tablets from Ashurbanipal's library were unearthed in the 19th century. Mixed among accounts of trade, laws, and rituals were texts that listed stars and planetary movements. Some of these lists bear striking similarity to catalogues made millennia later by Greek astronomers, yet the Mesopotamian records predate them by centuries. The consistency of their observation suggests not chance but a deliberate effort to map the skies. These star records were not random notes, but part of a structured system. Scholars now know that Babylonian astronomers used detailed methods to track the paths of Venus, Jupiter, and the Moon. They even recognized repeating cycles, recording them carefully across generations. The so-called mold-pin tablets, copied around 1000 BCE, but based on earlier traditions, contains a vast star catalogue. The precision of these tablets has startled modern researchers who see in them the work of astronomers who knew the sky with both patience and skill. Beyond mere observation, certain fragments appear to extend. A damaged tablet known as the planisphere held in the British Museum has stirred debate for decades. That some interpreters believe it records a specific astronomical event, perhaps even an unusual sighting such as a meteor impact around 3000 BCE. The tablet's mixture of symbols, numbers, and star references is dense and difficult to decode, leaving room for both scholarly caution and speculation about its true purpose. The fascination deepens with the way these ancient records align with modern astronomy. Certain constellations drawn in Mesopotamian records match those still used today, such as Taurus, Leo, and Scorpius. The shapes are close enough that their survival through thousands of years seems unlikely to be a coincidence. Instead, it points to a tradition of star mapping that may have been handed down, refined, and preserved across different cultures and epochs. So some scholars argue that these maps were not scientific in the modern sense, but deeply tied to ritual and divination. For Mesopotamian priests, the heavens were a stage upon which the gods spoke their will. An eclipse might foretell disaster, while the rising of Venus could signal favour. Even so, the accuracy of their record suggests that their religious goals required precise data. What appears to us as astronomy may have been for them the foundation of prophecy. The question of method remains a puzzle. Without telescopes, how did they chart planetary paths so carefully? One answer lies in the sheer dedication of long-term observation. Generations of scribes may have watched the skies nightly, writing down positions and movements with relentless discipline. The combined memory of centuries could produce a map of surprising accuracy, though the endurance of such effort is hard to imagine in a world so vulnerable to war and upheaval. Evidence of mathematical techniques adds another layer of intrigue. Recent studies of Babylonian tablets from around 350 BCE reveal the use of geometric methods to predict the motion of Jupiter. These calculations were once thought to have originated in medieval Europe. Yet here they appear in Mesopotamia centuries earlier. The sophistication of such work raises doubts about how much knowledge has been lost between antiquity and today. Beyond Mesopotamia, echoes of these star maps appear in unexpected places. Later Greek astronomy credited to figures like Hipparchus and Tommy bears striking similarities to Babylonian records. This suggests that the foundations of Western astronomy were not purely Greek inventions, but inherited from much older sources. The continuity of certain constellations across cultures strengthens the idea of a shared sky chart that travelled through time. Shadows of uncertainty remain. Some tablets describe star groupings that do not match the visible sky as we know it. Interpretations vary. They could reflect shifts in the heavens due to the precession of the equinoxes, or they might represent constellations lost in translation. In rare cases, scholars have suggested the possibility of misidentified astronomical phenomena, such as comets or novas recorded by ancient eyes, but not recognized for what they were. The endurance of these maps also raises questions about their intended use. Were they purely practical, guiding agriculture and calendars, or were they symbolic, aligning earthly rule with cosmic order? Kings of Mesopotamia often sought legitimacy through connection to the stars, claiming that their reigns mirrored divine will. To hold the knowledge of the heavens may have been as much a political tool as a scientific one. Modern technology has allowed researchers to re-examine old finds with fresh eyes. Digital imaging and new translations sometimes reveal details overlooked for decades. In some cases, what once seemed like abstract marks are reinterpreted as accurate star positions. The possibility remains that other tablets still buried or awaiting study could expand our understanding of just how far ancient star-gazing reached. The survival of these records through fire, conquest and time feels unlikely. Yet here they are, fragments of a night sky preserved in clay. They whisper of men and women who stood beneath the same stars we see today, tracing lines and seeking meaning. Their vision of the cosmos was not ours, yet the precision of their records cannot be dismissed. In the end, these unexplained maps remind us that the past may have contained knowledge that we only partly understand, knowledge that continues to shimmer half-revealed like stars glimpsed through broken clouds. The Enuma Elish creation story. From the ruins of Nineveh, the clay fragments holding the Enuma Elish emerged during 19th century excavations. Buried beneath the debris of the Assyrian Royal Library, they lay silent for centuries before being brought to light. When pieced together, these tablets revealed not just a tale of gods and battles, but one of the earliest surviving accounts of how the world was thought to have begun. The name Enuma Elish comes from its first line, which translates to when on high. The words introduce a world before order, a time when only swirling waters existed. Apsu, the fresh water, and Tiamat, the salt water, mingled together, and from them the first gods arose. In this opening, creation is not gentle but restless, setting the stage for a drama that would shape how Mesopotamians understood the universe. As the story unfolds, conflict quickly takes center stage. Younger gods disturb the calm of Apsu, whose anger drives him to plot their destruction. Tiamat, though at first supportive, eventually joins in vengeance, unleashing monstrous forces against the new generation. This rebellion between parents and children becomes the foundation of the cosmic struggle that lies at the heart of the myth. The god A, known also as Enki, acts with cunning and defeats Apsu, ending his rule of the waters. Yet victory is fleeting, for Tiamat remains, gathering storms and beasts to wage her own war. Out of this turmoil emerges Marduk, a younger deity whose power and resolve mark him as the champion of the gods. His rise would mirror the growing importance of Babylon, whose people came to see him as their protector and king of the heavens. Marduk's battle with Tiamat is described in vivid and violent images. Armed with a net, bow, and storm winds, he confronts the great sea dragon. The clash is not just between two figures, but between chaos and order itself. In the end, Marduk splits Tiamat's body in two, her one half forming the sky, the other the earth. Creation here is born from destruction, and the very shape of the cosmos is drawn from the remains of the defeated goddess. With victory secured, Marduk organizes the universe. He fixes the paths of the sun, moon, and stars, assigns roles to the gods, and sets boundaries for waters and lands. What had been formless now gains structure, echoing the shift from wild nature to the ordered life of cities and kingdoms. The myth reflects not only belief, but also the deep Mesopotamian concern with balance, law, and the rhythms of the heavens. The story continues with the creation of humanity, though people play only a small part compared to the gods. From the blood of Kingu, Tiamat's chosen commander, humans are fashioned. Their purpose is clear: to serve the gods, to perform their labours, and to sustain them through offerings and rituals. This vision places humanity not at the centre, but as attendants to divine powers, a view that shaped Mesopotamian religion and society. When the Enuma Elish was recited during the Babylonian New Year festival, it was more than storytelling. The ritual reaffirmed the order of the world and the supremacy of Marduk. Priests and rulers alike heard in it a divine endorsement of Babylon's power, linking earthly kingship to cosmic authority. The myth was not frozen in clay, but lived in the rhythms of ceremony, binding people, city, and cosmos together. Scholars have long compared the Enuma Elish to other ancient traditions. Its themes of water, chaos, and divine combat echo in later cultures, even appearing in distant texts such as the Hebrew Bible. The parallels raise questions about how stories travelled, shifted, and intertwined across lands and centuries. Was the Enuma Elish unique to Babylon? Or was it part of a much wider tapestry of creation myths that influenced one another in unseen ways? Broken though it is, the Enuma Elish still speaks of how humans once struggled with life's greatest mysteries. Instead of abstract reasoning, they told stories of gods, storms, and struggles that mirrored their own battles with nature and society. The survival of these tablets allows us to glimpse how myth was used not only to explain but also to give structure to a world that often felt hostile and unpredictable. In the surviving text, gaps remain as countless lines of the Enuma Elish are damaged or missing. What we have may only be a portion of the full story, leaving room for speculation about what was lost. The silences in the clay are as striking as the words themselves, inviting us to imagine what other visions of creation once circulated but never survived. Beginning with waters and ending with a deity, the fragments whisper a story whose complete truth seems always just out of reach. Unusual depictions of gods. The walls of Mesopotamian temples once held images that startled even the people who worshipped before them. Stone carvings and clay seals revealed gods with wings, horns, and hybrid forms that blurred the line between human and animal. These depictions did more than decorate. They carried messages about power, mystery, and forces beyond ordinary human understanding. Yet the exact reasons for such striking forms remain uncertain. On many cylinder seals, if the gods appear larger than mortals, towering over priests and kings, their scale alone sets them apart, yet artists also gave them features that defied nature. The god Ninurta, for example, was sometimes shown with a lion-headed mace, that acted as if it had life of its own. In such images, the familiar and the impossible met in ways that still puzzle researchers. Horns were a common marker of divine status. Many gods are depicted wearing horned crowns, sometimes with as many as 7 pairs stacked upward. Unlike earthly headgear, these crowns were not meant to suggest royalty, but to show an overwhelming and otherworldly strength. Their exaggerated form made the gods seem distant from the human world, hinting at forces that could not be tamed. Wings, too, appear in some depictions, and most notably in images of protective spirits and deities tied to the heavens. The figure of Asher, chief god of the Assyrians, was often portrayed inside a winged disc as if hovering above earthly realms. Scholars debate whether these wings symbolized flight, the sun, or divine presence itself. What remains clear is that the image carried an impression of movement and authority impossible to mistake. Some carvings present gods with animal features that appear unsettling even today. The goddess Lama is shown with human form, but often leads or protects worshippers in the company of strange creatures. In other scenes, deities command bulls with human heads or face guardians shaped like lions with wings. These forms may have been intended as symbols of combined strength, but they also leave behind a sense of enigma that resists full explanation. Not all depictions were fierce or intimidating. The god, known for wisdom and water, sometimes appears with streams flowing from his shoulders, populated by fish. This image is less about terror than about abundance. Yet its strangeness cannot be ignored. A human body joined with flowing water makes sense in myth, but when carved in stone it takes on a surreal quality that invites deeper questions. In the Temple of Ishtar, the goddess of love and war, statues often portrayed her with weapons in hand while standing upon lions. The dual nature of her character, both nurturing and violent, was expressed through this unusual imagery. To those who entered her temple, the sight must have been overwhelming, as if beauty and danger were inseparable. Her image challenged simple interpretation, just as her myths resisted easy resolution. Even more perplexing are figures found on boundary stones called kaduru. These stones bore symbols instead of full images, often combining shapes that represented different gods. A crescent for Sin, the moon god, might stand beside a star for Ishtar and a lightning fork for Adad. The presence of so many divine marks on a single stone made the boundary sacred, yet also raised the question of why abstract symbols replaced physical depictions. The choice suggests layers of meaning now difficult to recover. The strangeness of these images may partly reflect the desire to capture powers that could not be seen directly. For the people of Mesopotamia, the gods were not human in form, even if they sometimes wore human faces. They were forces of nature, key rulers of storms, rivers, and the underworld, and so their images merged the traits of many beings. Still, it is striking how consistently artists chose to portray them in forms that provoked both awe and confusion. What troubles scholars most is how little explanation survives in writing. Myths tell us stories, but they rarely describe why a god wore horns or why wings frame certain figures. The imagery seems to have spoken a language understood at the time but left untranslated in texts. Without those keys, we are left with visual mysteries that resist complete interpretation. Contemporary researchers have tried to trace these forms to earlier cultures, suggesting that some winged or horned figures came from contacts with neighbouring lands. Yet Mesopotamian artists transformed these influences into something distinct, shaping an iconography that endured for centuries. The survival of these images across time shows how important they were, but not why they were chosen in the first place. Standing before these depictions today, whether in museum cases or crumbling ruins, one is struck by the same sense of otherness that ancient worshippers must have felt. The gods are close enough to recognize yet distant enough to unsettle, their forms bridging the gap between the natural and the impossible. Their images remain as powerful as their silence, leaving us to wonder what truths they were meant to hold. In the gaze of horned crowns and winged forms, there lingers the impression that these gods were meant to be more than seen. They were meant to remind humanity that the divine would never be fully known. Knowledge of the human body. Covered in precise wedge-shaped script, the clay tablets have unveiled surprising insights into the minds of the ancient Sumerians. Among their records of trade, farming, and myth, some texts describe the human body with a precision that seems far beyond what one might expect from a civilization that lived more than 4,000 years ago. These writings open a window into how the earliest doctors, priests, and scribes thought about flesh, bone, and breath. The city of Nipper produced many fragments that show medical interest. One tablet from around 2000 BC, ECE lists parts of the body in order moving from the head downward, naming the ears, the nose, the tongue, and the internal organs. This structure suggests a systematic attempt to map the body. The order itself reveals a kind of logic, and as if the scribes were trying to give shape to knowledge rather than simply listing what they observed. Other texts go further, describing ailments in different parts of the body. Some tablets detail swelling in the hands or pain in the chest, while others speak of bleeding from the nose or problems with the stomach. What is remarkable is the way these symptoms were grouped. Instead of being scattered, they were tied to specific body regions, showing an awareness that the body was divided into interconnected zones. The Edwin Smith papyrus from Egypt is often celebrated as one of the earliest medical documents, but Mesopotamian records suggest that similar traditions were forming independently in Sumer. The tablets discovered at Ur and Sippar reveal that Sumerian healers could distinguish between diseases caused by physical injury and those thought to come from unseen forces. This separation shows that they were not simply treating illness as random, but as something that could be studied and categorized. Descriptions of veins and arteries appear in some later Akkadian texts, where the body is said to contain channels through which life flows. These channels were not explained with the same clarity as modern circulation. Yet the recognition that the body carried fluids in specific paths was a step toward a greater understanding. Such observations may have come from the experience of treating wounds in battle or accidents in farming. The flow of blood was impossible to ignore. The Sumerians also studied the pulse, though not in the modern sense of measuring heart rate. In certain texts, healers are instructed to place their hands upon the body to feel the life within. The idea that touch could reveal health marks one of the earliest traces of a diagnostic method. Even if their reasoning was framed in spiritual terms, the practice suggests careful attention to physical signs. Incantations often accompany treatment, and to modernize, this may seem less like medicine and more like ritual. Yet the mixing of herbs, oils, and procedures shows a dual understanding that the human body responded both to the natural world and to forces beyond human control. The use of willow, juniper, and other plants hints at an empirical tradition passed down through repeated trial, hidden within the language of prayer. Headaches, for example, were described in ways that suggest close observation. Tablets refer to pain that grips like a band or presses as a weight. Terms that echoes description are still used today. While they lacked knowledge of nerves or the brain structure, their attempt to describe pain patterns shows how carefully they listened to sufferers. This suggests that medical practice involves more than ritual. It required attention to the details of human experience. Sumerian texts also preserve surgical references, though limited. There are hints that abscesses were lanced and wounds cleaned with beer or wine, substances that acted as mild antiseptics. The survival of patients in an age without modern medicine may have seemed miraculous, but it was also shaped by the practical skills of those who handled injuries with some understanding of cause and effect. One of the most striking mysteries lies in how the Sumerians wrote about the liver. The liver was seen as the seat of life, a source of omens and health alike. Priests practiced hepatoscopy, examining the livers of animals for signs. But they also tied the organ to the health of humans. The focus on this single part of the body raises questions about how much they understood anatomy, and whether their repeated attention to it hinted at deeper knowledge gained through experience. The boundaries between science and belief blur in these texts. Illness was often explained as the work of demons or the result of anger from the gods. Yet alongside these explanations were practical observations of swelling, fever, and infection. The ability to record these details in writing meant that knowledge could be preserved and shared, forming a chain of learning that reached far beyond any one healer's life. Archaeologists and historians still debate how much of this knowledge was symbolic and how much reflected a true study of anatomy. Unlike later Greek medicine, Sumerian thought left little in the way of explicit theory, but the fragments we have show a culture grappling with the complexity of the human form. What remains most mysterious is how far they advanced without the benefit of systematic dissection or the tools that later civilizations would rely on. Quiet in what they record, the clay tablets nonetheless reveal upon careful reading a vision of humanity struggling to comprehend life's delicate framework. Their words suggest that the human body was not simply a vessel for divine punishment or blessing, but a system that could be known, treated, and sometimes healed. In these ancient records of flesh and spirit, we glimpse knowledge both familiar and elusive, as if the first map of the human body survives only in fragments, the astronomical ceiling of Sen-Envor. The first time scholars saw the ceiling fragments from Senut's tomb, they were struck by a beauty that seemed almost impossible for the era. The painted wood glimmered faintly under the soft light, revealing constellations drawn with precision. Scholars at the time in the early 20th century, working near modern-day Luxor, Egypt, noted that the placement of the stars was unlike anything seen in other tombs of the 18th dynasty. The work seemed deliberate, almost scientific, as though the artist had carefully observed the heavens for years before committing them to wooden pigment. Senmut, the royal architect and advisor to Queen Hatshepsut, lived around 14 to 70 BCE. He oversaw massive building projects and held a close position in the court, which gave him access to the latest knowledge of the time. The ceiling in his tomb, now catalogued as Tomb TT71, shows two main sections, one depicting the northern constellations and the other the southern sky. Modern astronomers have compared the layout to star charts, and the alignment suggests knowledge of precession, a concept thought to have been understood much later. The northern section features a constellation identified today as Ursa Major, along with smaller star groupings that correspond to planets and lesser-known constellations. The positions of these celestial bodies appear to reflect their locations as they would have been observed in the 15th century BCE. But this precision raises questions. How could Senis, or whoever guided the illustrations, have tracked the stars so accurately without telescopes or modern instruments? Ancient texts do reference star observations for agriculture, but nothing matches the complexity found here. The southern section contains Sirius, Orion, and other bright stars painted in rich colours that have survived thousands of years. Archaeologists have noted that some star placements on the ceiling correspond not just to positions in the sky, but also to their movement over time. This implies an understanding of long-term celestial cycles. Scholars like Ra Parker in the mid-10th century studied Egyptian calendars and found that knowledge of Sirius's helical rising was crucial for predicting the Nile flood. But the ceiling shows a level of detail that surpasses simple agricultural necessity. Researchers also observed that the ceiling divides the sky into hemispheres using a central band that may represent the Milky Way. This division is not merely decorative, it mirrors the way later Greek astronomers would map the heavens. The thought that such an advanced conceptualization existed over a millennium earlier is unsettling. How did the Egyptians acquire such knowledge? Some argue that it was inherited through centuries of careful observation, yet there is no surviving record explaining the methods used to compile such a precise chart. In addition to stars, the ceiling includes depictions of planets. Venus, Jupiter, and Saturn appear as small circles connected by lines, suggesting the artist understood their movement relative to the stars. A modern astronomy confirms that some of these alignments match planetary positions during Senenut's lifetime. Scholars like Otto Neugebauer have highlighted that this knowledge hints at observational sophistication comparable to civilizations much later in history. Yet the Egyptian texts provide no clear explanation of planetary theory or mathematics that could produce such accurate representations. The ceiling also features Dan, which are divisions of the sky used in Egyptian astrology and timekeeping. Each decan represents 10 days, and their arrangement on the ceiling seems to match the stars that rise with each Dan. This system allowed the Egyptians to divide the night and track time with unusual precision. For ordinary people, this might have been purely symbolic, but in a royal tomb, and it shows that astronomical knowledge had ceremonial and practical importance, bridging science and religion in ways modern scholars still struggle to understand fully. The craftsmanship itself adds to the mystery. Each star is rendered with care, often surrounded by a subtle halo to indicate brightness or importance. Colours are intentionally chosen, gold for prominent stars, red for planets, and blue for the general background sky. This suggests a sophisticated symbolic language that conveys astronomical information beyond what words alone could describe. The labour involved must have required not only artistic skill, but also mathematical understanding, a combination rarely documented in surviving Egyptian records. And it has been proposed by some scholars that the ceiling functioned as an instructional tool for priests or apprentice astronomers. If so, it would indicate an institutionalized system of knowledge transfer, but there is no direct evidence of written guides, notebooks, or instructional texts accompanying the ceiling. The precision and scale imply more than casual observation. Yet, the methods remain hidden in the shadows of history. Scholars can only infer techniques from the results. and those results are strikingly advanced for the period. Every attempt to reconstruct the celestial map in the tomb brings fresh surprises. Modern planetarium software allows astronomers to model the sky as it would have appeared over Luxor in 1470 BCE, and the correspondence with the painted constellations is remarkable. The level of exactitude down to small shifts in stellar positions suggests that the Egyptians observed the night sky over decades or even generations. Such continuity of observation implies a society deeply attuned to the cosmos, yet one that left almost no explanation for its findings. A sense of awe greets visitors to the site, even in the present day. The ceiling invites contemplation, drawing the eye upward as if to transport observers to the night sky itself. The combination of art, science, and symbolism forms a puzzle that remains unsolved. How did an ancient architect integrate astronomical data with religious and artistic traditions in a single cohesive vision? The answer lies buried beneath layers of history, waiting for someone to uncover the method behind the masterpiece. The astronomical ceiling of Senmut remains one of the oldest known examples of precise celestial mapping, yet its full meaning continues to elude historians and astronomers alike, as if the night sky itself still guards its secrets. Evidence of early surgery. The first discovery that hinted at advanced medical practices came from the deserts of ancient Mesopotamia. Archaeologists unearthed skulls that bore small, carefully cut holes. At first, these injuries were thought to be accidents, but closer inspection revealed smooth edges indicating deliberate intervention. In 1931, at the site of Tel Abas Alabik near modern Iraq, researchers noted that some skulls showed signs of healing. Whoever performed these procedures had not only understood basic anatomy, but also the need for care and cleanliness. Medical historian Henry Sigarist later examined these skulls and emphasized that the holes were made with tools, possibly stone or bronze instruments, rather than by blunt trauma. The level of precision suggests that early surgeons could control bleeding and avoid critical areas of the brain. These findings challenged assumptions that complex surgery only appeared in classical civilizations like Greece or Rome. The practice known as trepation had already begun thousands of years earlier than previously believed. Evidence also emerged from ancient Egypt, where mummies showed remarkable signs of surgical knowledge. A 350-year-old mummy identified in the 20th century in the Valley of the Kings had a fractured rib that appeared to have been set and allowed to heal. A medical specialist studying the remains concluded that the fracture had been treated deliberately, as the bones aligned correctly, and there were signs of inflammation consistent with healing. This discovery suggested that physicians or healers understood how to stabilize broken bones and manage recovery long before modern splints or casts were invented. Even more surprising were cases in the Indus Valley, in what is now Pakistan and northwest India. Excavations in the 1920s revealed skeletal remains with precise incisions on bones, often accompanied by evidence of infection that had resolved. These findings indicated that surgical intervention was sometimes life-saving, and that early civilizations observed their patients after operations. The skill involved implies knowledge of anatomy and cautious application of tools, and showing a level of expertise previously thought impossible in the 3rd millennium BCE. Artifacts further support these findings. In Mesopotamia, clay tablets dating back to 2100 BCE include medical instructions for treating wounds and injuries. Some texts describe methods for stopping bleeding and managing pain with plant-based substances. These records do not merely list remedies, they provide procedural guidance. Scholars studying these tablets note that the level of detail suggests hands-on experience and careful observation of outcomes, implying that surgery was not just experimental but a practice science. The risk of infection was significant in ancient times, yet evidence shows that early surgeons took precautions. Charred plant materials and antiseptic pastes described in Egyptian medical papyri, such as the Edwin Smith papyrus around 1600 BCE, were applied to wounds to prevent decay. One case details the treatment of a head injury where the text recommends cleaning the wound, removing foreign material, and covering it with a protective dressing. This approach closely resembles modern antiseptic principles, revealing a surprisingly sophisticated understanding of hygiene in surgical contexts. Trepation, the deliberate opening of the skull, appears in several cultures across continents. In Peru, burials dating back to 2000 BCE displays skulls with healed openings similar to those in Mesopotamia. The recurrence of this practice in geographically separated societies raises questions about the transmission of medical knowledge. that whether developed independently or through cultural exchange, these surgical interventions indicate a shared recognition of the human body's vulnerabilities and the potential for intervention. The tools themselves provide insight into the precision of early surgery. Bronze scalpels, walls, and chisels have been found in Mesopotamian and Egyptian sites. Microscopic analysis shows they were sharpened carefully and sometimes polished to reduce tissue damage. Archaeologists have noted that the variety of instruments corresponds with different surgical tasks, from small incisions to larger bonework. Such differentiation suggests specialization among practitioners, hinting at a class of trained individuals devoted to healing and medical experimentation. Patients too left their mark on history. Some skeletal evidence indicates that survival rates were higher than expected. Healing bones and signs of regrowth around skull openings confirm that the procedures were not always fatal. This challenges the notion that ancient surgery was haphazard. In fact, these early doctors demonstrated patience, skill, and careful attention, often monitoring patients over weeks or months. Their success depended not only on tools and techniques, but also on observation, knowledge of the body, and the use of natural remedies to aid recovery. Some modern scholars suggest that ritual and medicine were intertwined. Healing could involve prayers, protective charms, and symbolic incisions, blurring the line between spiritual and medical practice. In Mesopotamia, textual references to illnesses often invoked gods, while instructions for treatment combined practical care with ritual. This dual approach may have provided psychological comfort and practical benefit, reinforcing the healer's authority while reducing the patient's stress, which could have aided recovery. The cumulative evidence presents a compelling picture. Surgery in the ancient world was not merely an accidental discovery, but a practice skill that spanned multiple regions and centuries. Mesopotamian, Egyptian, and Indus Valley cultures all demonstrate an understanding of anatomy, careful handling of instruments, post-operative care, and even preventative hygiene. While their methods were primitive compared to today's standards, the success of these early surgeons challenges assumptions about the timeline of medical knowledge. The study of these ancient practices continues to inspire modern medicine. Researchers use CT scans and forensic techniques to analyze skulls and bones, revealing details invisible to the naked eye. Every healed fracture or cranial incision tells a story of courage, observation, and ingenuity. These early healers operated in a world without modern hospitals or anesthesia, yet their achievements echo across millennia, offering a glimpse of skill and knowledge that might have been lost but for careful archaeological work. The evidence of early surgery is a silent testimony etched into bones and preserved in texts that the human drive to understand and heal the body existed long before modern science, and its full depth may still be waiting to be uncovered. Agricultural origins. The earliest signs of agriculture appeared along the fertile banks of rivers where water nourished the land. In the Levant near present-day Israel and Jordan, archaeologists have uncovered sites dating to around 10,000 BCE, where wild grains were collected and planted. At places like Jericho and Abu Huraira, evidence shows that people began to transition from foraging to cultivating plants, marking the first steps toward organized food production. This change transformed the way humans lived, allowing them to settle in one place rather than constantly move in search of resources. At Abu Huraira, excavations revealed remnants of corn and emmer wheat, along with storage pits for seeds. These discoveries suggest that early communities had learned not only to plant crops, but also to manage and store them. The clay and stone tools found alongside these pits indicate methods for grinding grain into flour. The combination of cultivation, storage, and processing shows that agriculture requires planning, experimentation, and careful observation of the natural environment. Animal domestication emerged alongside crop cultivation. In the Zagros Mountains of modern Iran, evidence from around 9000 BCE shows that goats and sheep were selectively bred for human use. By controlling herds and guiding their breeding, early farmers could rely on meat, milk, and wool in a predictable way. This relationship between humans and animals transformed societies, creating stability that allowed villages to expand and new settlements to form. Environmental conditions played a crucial role in the development of agriculture. The end of the last ice age brought warmer temperatures and more consistent rainfall in parts of the Fertile Crescent. These changes made it possible to grow a variety of plants in a single region. Archaeologists studying pollen samples and sediment layers in the Tigris-Euphrates basin have traced shifts in vegetation that match the emergence of early fields and cultivated plots. These natural changes encouraged humans to experiment with planting and harvesting in ways they had never attempted before. The tools of early agriculture also reveal an unexpected sophistication. Flint sickles from Jericho, dating to around 8000 BCE, show signs of repeated use in cutting grass and cereal stalks. The edges were often polished, suggesting that early farmers understood the value of maintaining sharp tools for efficiency. And stone mortars and grinding slabs found in these sites indicate that processing grain into edible forms was already well established. These tools were not simple implements. They were carefully designed to support a growing agricultural lifestyle. Water management became increasingly important as communities relied on crops for survival. In Mesopotamia, evidence from the Ubaid period around 6500 BCE shows the earliest irrigation canals. Small channels diverted water from rivers to fields, allowing farmers to control moisture levels and protect plants from drought. These canals required cooperation and planning, indicating that early agriculture involved social organization in addition to technical knowledge. Communities had to work together to dig, maintain, and use these irrigation systems effectively. The seeds and plants themselves were carefully selected for desirable traits. Archaeologists studying ancient wheat and barley varieties from sites across the Fertile Crescent have noted that early farmers favored grains with larger seeds, higher yields, and easier processing characteristics. This selective cultivation represents one of the first forms of intentional breeding. It demonstrates that humans were not passive observers of nature. They were actively shaping it to suit their needs and improve survival chances. The shift to agriculture had profound cultural effects. Permanent settlements allowed for the construction of durable homes and storage facilities, which are evident in sites like Katal Hoyuk in Turkey, dating to around 7500 BCE. These structures indicate that people invested in long-term habitation, reflecting confidence in their ability to produce enough food. Artifacts, figurines, and symbolic carvings found in these settlements suggest that agricultural life influenced beliefs, rituals, and social hierarchies, linking the material and spiritual aspects of early communities. Trade networks began to form as a result of surplus production. Communities with abundant crops could exchange goods with neighbouring groups that had different resources. Evidence from sites in northern Mesopotamia and the Levant shows the movement of obsidian, flint, and shell, demonstrating that agriculture supported not only food security, but also economic interaction. This early trade helped spread knowledge, techniques, and even plant varieties across regions, accelerating the development of complex societies. Agricultural innovation did not happen uniformly. Some areas like the Nile Valley in Egypt developed irrigation and planting practices independently from Mesopotamia. Sites such as Merimda Beni Saloma, dating to around 5000 BCE, show early reliance on wheat and barley alongside domesticated cattle and goats. Despite geographic separation, these societies discovered similar solutions for cultivating crops, suggesting that the human drive to experiment, observe, and adapt was universal. The evidence of early agriculture paints a picture of human ingenuity and persistence. From planting seeds and domesticating animals to creating tools and managing water, these early farmers transformed the landscape and society. They laid the foundation for civilization itself, proving that careful observation, trial and error, and cooperation could turn wild landscapes into sustaining communities. Each field, canal, and storage pit tells a story of experimentation and adaptation that still shapes our world today. As the first crops took root and villages grew, humans began to realize that the earth could be guided and shaped, a revelation that would forever change the balance between nature and culture, music, and the oldest known songs. In the flickering light of ancient temples, the first sounds of music may have echoed across stone walls, connecting humans to something beyond themselves. The oldest known song, discovered on a clay tablet from Ugarit in modern-day Syria, dates back to around 1400 BCE. Written in cuneiform script, it contains musical notations alongside words, revealing that melodies were carefully composed rather than improvised. This tablet, now preserved in the National Museum of Damascus, gives a rare glimpse into the artistic life of early civilizations, showing that humans were already thinking in terms of rhythm, pitch, and harmony. Archaeologists have found other early instruments that hint at musical practices far older than the Ugarit. Flint flutes from Germany, made around 40,000 years ago, suggest that prehistoric humans experimented with sound long before written notation existed. Hollowed bones with carefully placed holes allowed for variations in pitch, showing an understanding of musical scale even in the Paleolithic period. These instruments indicate that music was not merely entertainment. It may have played a role in ritual, storytelling, and social cohesion among small hunter-gatherer groups. In Mesopotamia, lyres and harps were common, often buried with the dead to accompany them into the afterlife. Excavations in the royal cemetery date to around 2500 BCEE, uncovered beautifully crafted stringed instruments with gold and lapis lazuli decorations. The attention to detail suggests that music held spiritual or ceremonial importance. Scholars studying the lyre's structure have discovered that they were capable of producing complex melodies, indicating a sophisticated understanding of sound and resonance that would shape future musical traditions. The notation on the Uga tablet provides evidence of theory, not just practice. Marks indicate which strings to pluck and the relative pitch of each note, showing that musicians could recreate the same song consistently. This early system of recording music suggests that communities valued preserving their compositions much as they preserved texts, laws, and stories. It reflects an understanding that music was a structured language capable of conveying emotion, meaning, and memory across generations. Music was closely linked to religious practice in the ancient world. Temples in Mesopotamia, such as those dedicated to Nibu in Babylon, contained musicians whose role was to honor the gods and accompany rituals. Hymns inscribed on clay tablets were performed with the lyre, drum, and flute. The combination of voice and instruments created patterns of sound that were both meditative and evocative, connecting human participants to divine presence. An archaeological evidence suggests that some pieces were highly elaborate with multiple musicians coordinating timing and harmony. Even ordinary daily life in early societies involved music. People may have sung while grinding grain, weaving or hearing animals. Ethnographic studies of later cultures in the same regions suggest that songs were used to pass down knowledge, count time, or signal tasks. These practical songs likely influenced ceremonial music, forming a continuous thread between work, ritual, and play. The ubiquity of sound in everyday life indicates that music shaped human perception of time, rhythm, and social interaction from its earliest stages. The instruments themselves show remarkable innovation. Bone flutes, reed pipes, and stringed lyres were tuned with precision. In the Sumerian city of Lagash, an artistic depictions of musicians demonstrate knowledge of hand placement, finger technique, and string tension. Some lyres featured resonators made from tortoise shells or wooden boxes, enhancing volume and tonal quality. These technical advancements indicate that early humans were not only inspired by music, but also dedicated themselves to engineering instruments capable of producing a wide range of sounds across cultures. Music could have created connections. Trade and conquest in the ancient Near East spread instruments, styles, and compositions over vast distances. Tablets from Hittite and Huron cities suggest that songs composed in one region were performed in another, sometimes with local adaptations. This exchange of musical knowledge demonstrates that music, like language and writing, was part of the broader movement of culture, ideas and technology that shaped early civilizations. Performers, whether professionals or community members, developed early forms of notation to maintain accuracy. Some cuneiform tablets include instructions about rhythm, phrasing, and even the emotional tone of performance. These details imply that musicians were trained to interpret written guidance much as modern performers read sheet music. The existence of training and notation underscores music's importance as both an art form and a means of social or spiritual communication. Mesopotamian artistic works, particularly reliefs and cylinder seals, illustrate musicians playing as a group. Harps, lyres, and drums appear alongside dancers and singers, suggesting coordinated performance rather than solo improvisation. These depictions highlight the social dimension of music, emphasizing collaboration, timing, and shared experience. Music was not merely for private enjoyment, its structured community events strengthened bonds and celebrated shared identity. Surviving songs from Ugarit and other ancient sources still hold scholars and musicians in rapt attention. Attempts to reconstruct these melodies allow modern listeners to experience sounds that were heard 3 and 4 millennia ago. The process reveals both the continuity and evolution of musical understanding, reminding us that the impulse to create structure and share sound is a deeply human trait that stretches back to the dawn of civilization. From hollowed bones to intricately notated tablets, the history of music shows that humans have long sought to give form to sound. Each instrument, melody, and inscription speaks of creativity, ingenuity, and the desire to connect across time. Music shaped daily life, ritual and culture, leaving traces that continue to inform our understanding of the ancient world. Without voices or instruments, the first songs still echo, lingering to be heard once more. Unfinished mysteries of Eridu. Eridu rises from the shifting sands of southern Iraq, a city that whispers of beginnings no one fully understands. Considered by many scholars as one of the world's earliest cities, Eridu was established around 5400 BCE in the fertile lands of Sumer. Its ruins stretch across the plain with crumbling mud brick walls and temple foundations that suggest ambition and planning far beyond simple settlement. Archaeologists walk carefully among fragments of stone and clay, piecing together a city that once may have been a hub of religious and cultural power. Though its full story remains hidden beneath centuries of soil, the heart of Eridu was its temple, the Yabzu, dedicated to Enki, the god of water, wisdom, and creation. Layers of construction indicate repeated rebuilding over millennia, with each generation adding to the structure, yet never fully completing it. Excavations led by Leonard Woolley in the 1920s revealed that even the earliest foundations were carefully aligned, hinting at architectural knowledge that seems advanced for the period. Still, much about the temple's design and function remains a mystery. The meaning behind its precise layout, the purpose of its chambers, and the rituals that took place within are subjects of ongoing debate. Artifacts found in Eridu add to the intrigue. Clay tablets, some bearing early uniforms, suggest record-keeping, perhaps related to trade or ritual. Small figurines, tools, and pottery hint at daily life. Yet these items often appear in unusual contexts. Some are buried beneath temple floors as though offerings or acts of devotion were interwoven with construction. The reasons behind these depositions are unclear, leaving researchers to wonder if they were meant to appease the gods, mark a ceremonial moment, or serve another unknown purpose. Water played a crucial role in Eridu's story. The city was built near marshes fed by the Euphrates, allowing agriculture and settlement to flourish. Yet the relationship between Eridu and its water sources remains partially obscure. Evidence suggests the Sumerians engineered canals and ditches, managing irrigation with skill, but environmental shifts may have forced repeated adjustments. Some scholars propose that rising waters and silting led to periods of abandonment, though exact timelines are difficult to confirm. Eridu's survival and decline seem intertwined with forces humans could manipulate only partially. Burial practices at Eridu are another enigma. Graves have been found containing objects that seem ceremonial rather than practical. Some skeletons bear signs of careful positioning, while others include jewellery and symbolic items. These practices hint at complex beliefs about life, death, and the afterlife. But the specific meanings remain uncertain. Without written explanations, researchers must infer the intentions of those who lived and died here thousands of years ago, leaving room for many unanswered questions. The city also shows early evidence of social hierarchy. Large mud brick structures suggest administrative or elite use, distinct from smaller dwellings. Craftspeople likely worked with clay, stone, and metal, producing goods that hint at trade both local and long distance. Yet Eridu's political structure is largely unknown. How leaders maintained power, how decisions were made, and whether governance relied on religious authority, military strength, or community agreement remains a subject of speculation. Each discovery sheds light on some aspects of life, but deepens the sense of mystery in others. Eridu's connection to Sumerian mythology complicates the historical record. The city appears in texts as the first city created by the gods, linking it to divine favour and cosmic order. While mythology cannot be taken as literal history, these stories reflect the city's symbolic importance in early Mesopotamian culture. They hint at knowledge, beliefs, and ideals that shaped Eridu's people, offering glimpses of cultural life that material evidence alone cannot fully reveal. Archaeological work in Eridu faces challenges that add to its unfinished story. Layers of sediment, shifting river paths, and centuries of human activity make excavation difficult. Many areas remain unexcavated or partially studied, leaving large portions of the city unexplored. Each new dig uncovers fragments, but these often raise as many questions as they answer. Scholars must balance careful interpretation with the acknowledgement that our understanding of Eridu is incomplete, always provisional, and subject to revision as new evidence emerges. Despite centuries of study, Eridu continues to resist full explanation, Its temples, homes, and artifacts suggest a city that achieved cultural and technological sophistication while leaving many mysteries behind. The interplay of human endeavour, environmental change, and religious imagination created a place both remarkable and elusive. As researchers return season after season, they confront a landscape layered with history yet fractured by time, reminding them that some stories remain unfinished by design. The city of Eridu stands today as a testament to beginnings and questions that persist, a silent witness to knowledge that may never be fully recovered. The disappearance of the Sumerians, the land of southern Mesopotamia, once alive with the sounds of bustling cities, slowly grew silent by around 2000 BCE CE. Many of the great Sumerian city-states Urk, Lagash, and Eridu had declined, leaving behind ruins and memories of a civilization that had flourished for millennia. Archaeologists and historians have long studied the remnants, piecing together a story of decline. Yet no single explanation fully accounts for how the Sumerians, pioneers of writing, law, and urban life, seemed to vanish from their own lands. Environmental changes played a central role in the disappearance. The Euphrates and Tigris rivers, lifelines for agriculture, shifted courses over centuries, and sedimentation altered the fertility of the soil. Evidence from cores and excavations shows that once rich farmland became less productive, forcing communities to adapt or relocate. The canals and irrigation systems the Sumerians had perfected for centuries fell into disrepair, leaving crops vulnerable to drought and salinity. Without reliable food sources, city populations dwindled and smaller settlements were abandoned first, leaving larger cities exposed to additional stresses. Conflict and invasion further complicated survival. Sumerian cities were often in competition with one another and later faced incursions from external groups such as the Akkadians, Elamites, and Amorites. The Akkadian Empire rose around 2334 BCE. Sargon of Akkad absorbed many Sumerian territories. While the Sumerian language persisted in administration and literature for several centuries afterward, political control shifted away from Sumerian rulers, reducing their influence and accelerating cultural transformation. Disease may have contributed as well, though evidence is harder to confirm, and skeletal remains show signs of malnutrition and stress, suggesting that epidemics could have spread quickly in densely populated urban centres. Poor sanitation in cities built along rivers, combined with the breakdown of local governance, may have increased vulnerability to illness. Each generation likely faced greater challenges than the last, gradually weakening societal structures and eroding the stability that had once supported complex urban life. Pressures mounted, but Sumerian culture endured longer than might be expected. Their writing system, ununiform, continued to be used by the Akkadians and Babylonians for centuries, preserving laws, religious texts, and literary works. The Epic of Gilgamesh, hymns to deities, and administrative records remained in use, offering a bridge between past and present. However, over time, as the spoken language of the Sumerians faded, an assimilation into surrounding cultures obscured their distinct identity. What had been a living culture became a legacy preserved mainly in texts and archaeology. Trade and economic shifts also influenced the decline. The Sumerians had relied on long-distance trade for metals, timber, and other resources. As political control shifted and new powers dominated the region, trade networks were disrupted. Some cities lost access to essential materials, making construction, agriculture, and craft production more difficult. Economic hardship compounded the effects of environmental stress and conflict, leaving communities less resilient and more likely to disperse. Archaeological evidence highlights another factor: internal social strain. Elite classes controlled large portions of land and resources, while lower classes faced the pressures of taxation, labour obligations, and food scarcity. These inequalities may have weakened civic cohesion, making collective action to maintain irrigation or defend cities more difficult. In some regions, evidence suggests rapid abandonment rather than gradual decline, indicating that communities may have fractured under multiple simultaneous pressures. Religious transformation also marks the end of Sumerian dominance. Temples remained central to urban life, but shifts in worship and priestly authority mirrored political change. Deities once celebrated primarily in Sumerian temples became integrated into broader Mesopotamian pantheons, often under Akkadian names. Religious identity blended with incoming cultures, further blurring the distinct Sumerian presence. By the time the Babylonian Empire rose, Sumerians had largely ceased to exist as an independent people, though their gods, myths and ideas continued to shape the region. The disappearance of the Sumerians remains a puzzle in its entirety. Each factor, environmental change, invasion, disease, economic shifts, social tension, and religious adaptation, interacted in ways that are difficult to reconstruct fully. Scholars continue to debate which pressures were most decisive, but it is clear that the decline was neither sudden nor attributable to a single cause. Instead, it was the result of centuries of gradual transformation under multiple stresses that reshaped southern Mesopotamia. The echoes of Sumerian civilization continue to appear in surprising ways today. Their inventions, stories, and laws influenced later civilizations such as the Babylonians and Assyrians. Writing, mathematics, architecture, and religious thought from Sumer endured, seeding innovations that echo through history. Yet the people themselves, once masters of the plains between the Tigris and Euphrates, remain absent, leaving behind cities emptied of life and the lingering question of how a civilization so advanced could fade into silence. The mystery of the Sumerians' disappearance reminds us that even great societies are vulnerable. Their story of caution still whispers from Mesopotamia. Music legacy beyond time. Long after the cities of Sumer had been abandoned, the innovations quietly shaped the world. Clay tablets etched with ununiform survived centuries of conflict and natural decay, preserving laws, stories, and records of daily life. As scholars centuries later would study these texts to understand governance, trade, and religion in ways that showed the Sumerians were far ahead of their time. Their written language was not merely a tool for administration. It carried ideas, wisdom, and culture that could transcend generations. Mathematics and measurement were among the Sumerians' most enduring contributions. The sexdecimal system based on the number 60 influenced the way humans divide time and angles even today. Hours, minutes, and seconds, as well as 360-degree circles, trace their origin to Sumerian innovations. Evidence from tablets found in Ur and Nippur demonstrates that Sumerians used complex calculations for trade, construction, and astronomy. These practical applications became the foundation for subsequent civilizations, showing that their knowledge was not only advanced but adaptable. Architecture also left a lasting impression. The ziggurats of Eridu were more than religious centers. They were feats of engineering. Builders mastered mud brick construction, water management, and urban planning. Later cultures borrowed and improved upon these methods, and echoes of Sumerian design appear in the monumental structures of Babylon and Assyria. Even without the original communities, the influence of these architectural innovations persisted, guiding the development of cities for centuries. Sumerian law offered another legacy that reached beyond time. The Code of Namu, created around 2100 BCE, predates Hammurabi's famous code and illustrates an early commitment to justice and social order. The laws regulated property, marriage, and personal conduct, reflecting a sophisticated understanding of society by providing rules that emphasize fairness and accountability. The Sumerians set a precedent for legal systems that would evolve across the ancient Near East and later influence modern concepts of governance. The arts preserved stories and values that remain compelling today. Epic poems, hymns, and songs recorded on clay tablets reveal a deep awareness of human experience. The Epic of Gilgamesh, one of the earliest literary works, explores friendship, mortality, and the search for meaning. Through these texts, the Sumerians communicated ideas about life, death, and the divine that resonated far beyond their own era. Even as cities fell and languages changed, the emotions and narratives they captured continued to influence literature for millennia. A religious and mythological thought carried forward in subtle ways. Deities such as Inanna, Enlil, and Enki influenced the pantheons of later Mesopotamian cultures. Ritual practices, temple organization, and symbolic representations shaped how humans engaged with the sacred. Archaeologists have found continuity in religious iconography and ceremonial structures, demonstrating that Sumerian spiritual concepts informed the development of Babylonian, Assyrian, and even later Mediterranean beliefs. This continuity shows how ideas once created can endure even when the creators vanish. Science and observation were central to Sumerian achievement. Astronomy, cylindrical systems, and predictions of celestial events were recorded with care and precision. The abilities to chart stars, phases of the moon, And seasonal changes supported agriculture and ritual alike. Later civilizations inherited this knowledge, expanding on it to develop more sophisticated astronomical understanding. Sumerian observation laid the groundwork for measuring time, predicting floods, and organizing society according to the cycles of nature. Daily life also left traces that extended far beyond Sumer. Records of trade, labor, and household management reveal people who understood commerce, economics, and social organization. Markets, labor divisions, and standardized weights and measures allowed communities to thrive. These practices influenced neighboring regions and inspired systems that became integral to later civilizations. In every administrative record, there is evidence that Sumerians sought efficiency, accountability, and balance. There are principles that guided human societies long after their cities were gone. Even in modern times, their legacy continues to spark curiosity and research. Excavations at Uruk, Eridu, and Nippur uncover new insights, reminding scholars that the Sumerians' achievements were multifaceted. Museums around the world display artifacts that reflect creativity, skill, and intelligence, bridging thousands of years. Each discovery reinforces the idea that this civilization, though lost, continues to communicate with the present through the objects, texts, and ideas it left behind. Ultimately, the Sumerians demonstrate that influence is not measured solely by the survival of a people, but by the endurance of their knowledge and innovations. Their contributions in writing, law, architecture, mathematics, and spirituality form the bedrock of human civilization. They remind us that even when a culture disappears from the landscape, its ideas can persist, ripple through time, and shape the future in ways the original creators could scarcely imagine. And somewhere in the quiet of ancient ruins, that enduring voice of human ingenuity still whispers,